sanitizer. पानी कौन सा? Okay, good morning. PGTs in chemistry of all the EMRS. Now we come to the second phase of the chemistry program, subject chemistry. Now, I have already told you in my first session that how this examination will be conducted by the EMRS. So I don't want to repeat again. Now, on my left is today's research person, Professor Dr. Narsingh Sahu. He was an associate professor in the state of Arunachal Pradesh, and he has done his PhD from Banaras University, and he has got a lot of contribution in the educational field. So I don't want to become a bar between you people and Dr. Professor Narsingh Sahu. So I request Dr. Sahu to start his deliberation of the talk. Now, Dr. Sahu.
So welcome, good morning to you all. So Dr. Das has given you the brief introduction about me, and today we will start the subject electrochemistry, which has been given the short questions and some questionnaire type questions, that is MCQ, the choice based question answers. So in the brief case, electrochemistry, as we have already talked about before this class, that it deals with the electrolysis and the subjects of that is the conductance measurement, resistance, as well as specific resistance, and molar conductivity, equivalent conductivity, Paul's law, and redox oxidation reactions, that is the electrochemical cell, and the cell batteries, all these things. So we will deal with all these things. But beforehand, that electrochemistry, in that cases, we have two parameters in that cases, that is electrolysis and electrochemistry, that is electricity formation, that is chemical energy converts to electricity. So in that cases, as we have already done the electrolysis, which we have, that is the things, as we have already talked about this, that is the we have already talked about the first law of electrolysis and second law of electrolysis. That in the first law, that is the whatever the amount is produced, that is directly proportional to the amount of the quantity of electricity introduced, or that is the quantity of electricity produced in that case. So in that cases, as you have already done all these things, only 3 questions we will discuss it, and henceforth, as next, that is whatever the amount of electricity is passed, if the same quantity of electricity is passed, that is also directly proportional to the chemical equivalence of the metals or the system. So in that cases, we have already dealt with the first law and second law. Now coming to the next, that is the resistance, specific conductivity, and equivalent conductivity and molar conductivity. In that case, all these things, as we have already discussed it, just briefly I am giving the short hints. So that is, the resistance is directly proportional to the amount of electricity and inversely proportional to the current. And from that, the reciprocal of the resistance is known as the conductance. And similarly, the specific conductance is also the directly proportional to the length of the conductor and inversely proportional to the area of cross section of that conductor. So inverse of that specific resistance is known as specific conductance. So it is the specific conductance of 1 cubic centimeter of the solution, whichever the system is introduced. That means the electrode is passed through. Similarly, we will come to equivalent conductance. Equivalent conductance is also the amount of all the ions produced when 1 gram equivalent weight of the substance is taken certain volume, that is V. Same as the molar conductance, that is the 1 molecular weight of the substance when introduced to, or when is taken in a volume V, the total amount of the ions produced is the molar conductance. So they are also interrelated. So in that cases, we will discuss about the questions. In that cases, another thing is that whenever you are taking the concentration of the substances or the solution, concentration means whatever certain amount is present in a specific volume. So specific resistance or specific conductance in certain volume is fixed. When you decrease the concentration, specific resistance or a specific conductance also decreases. But in case of equivalent conductance and molar conductance, the equivalent conductance increases, molar conductance also increases due to decrease in concentration. That means we are diluting the solution. Diluting the solution means the amounts present or the ions present in that cases is also increased. Whereas the specific conductance is decreasing, because in 1 cubic centimeter of that volume, the number of ions present is also decreasing. So that it is the thing. Then coming to Colas law. Colas law means, so all the ions has contributed some conductance to the solution. So in that cases, the Colas law giving the conductance, the sum of the conductance of the positive ions and the negative ions produced in a solution, that gives the Colas law. That means in a definite volume or definite concentration, the amount of positive ions and negative ions formed, that contributes the conductance of the cell or the solution. So in that cases, the total, the molecular conductance or the equivalent conductance depends upon the number of ions formed, as a number of ions, that is positive ions and negative ions formed during the electrolysis, that contributes the resistance to the as the conductance to the solution. So phase wise we will discuss this, and we will be coming to that the short questions, whichever is, because that is in that cases, what do you mean by the difference between electrochemical cell and electrolytic cell? Electrochemical cell means the reaction, whatever the chemical, the electrolytes in the solution has given some reaction, and that produces the electricity when we are introduced the electrostool. But electrolytic cell means the electrolytes which are in the solution that produces directly the electricity. So that is the main difference between the electrochemical cell and the electrolytic cell. So if you are asked what is the illustrated difference between the electrochemical cell and electrolytic cell, so we have to mention it in this way, from the chemical reaction, whatever the energy is produced, that converts to electrical energy. But in case of electrolytic cell, the electrolytes which are is in the solution directly produces the electricity. This is main differences. Then state Colas law, as I have already told you, the Colas law, that is the contribution of the total molar conductivity to the solution of the electrolytic solution whenever it is present, or whenever you are taken in a solution medium that contributes the positive means cations, and negative ions, that is anions. So the conductances of each ion, that is positive, and the total sum is given as the Colas law. So in that cases, from the strong electrolytes, we can directly giving or directly calculate the total conductance of this system. But in case of dilute solutions, it is difficult, and that is why the Colas method is applied to that in calculating the total conductance of the weak electrolytes. So if it is given that calculate, how will you calculate the conductance lambda 0 of barium hydroxide with the help of this law? So in that cases, we will see that barium hydroxide. So that produces barium 2 plus OS minus. So the lambda 0 of barium hydroxide is equal to, it is one number, so lambda 0 of barium 2 plus 2 into lambda 0 is minus. So this gives the total conductance of barium hydroxide. Now, next is what is defined the term specific conductance and equivalent conductance. Specific conductance and equivalent conductance, as we have already discussed in the beginning, the specific conductance is the inverse of specific resistance. Inverse of specific resistance means, as we have already told, that is the specific resistance is rho, and 1 by rho is the specific conductance. So which is directly proportional to L by. So the conductance, because L is the length of the conductor and A is the area of the cross section of the conductor. So that is the amount of the conductance present in 1 cubic volume of the solution. So that is the specific conductance. Then what is the equivalent conductance? Equivalent conductance is the total amount of conductance present when 1 gram equivalent weight of the substance or the electrolyte result in V, that is the specific volume of a solution. So it is also given that the value, as we have discussed it sometimes. So that is represented as this is equivalent conductance, and that is K is the specific conductance multiplied by 1000 by the concentration. Concentration in the space of equivalent weight. So whatever the amount is taken in that cases, we can calculate in this fashion. So it is the volume. Whatever the volume is taken in terms of the concentration. So equivalent conductance of a solution is the product of the specific resistance or specific conductance multiplied by 1000 upon the concentration. Then concentration in terms of here, you can take equivalent, that is the normality. Normality is represented in terms of equivalent weight. And the molarity in this case of same as if we can take molarity same as that. Molarity. So that is the molar concentration in that. So in the both the cases, as you have seen that, as well, so equivalent conductance and molar conductance is the product of the specific conductance. So you see that the volume, whenever the volume is increased, the amount of specific conductance decreased, so that the product in that cases it is increasing. In both the cases, equivalent conductance and molar conductance. But in terms of the specific conductance, the amount of the ions present in 1 cubic volume of the volume of the solution is decreasing. That means the ionization is decreasing present in 1 cubic volume. That is 1 cubic centimeter of the solution. So that is the then describe the another thing. We will proceed for cells. First we will write the Daniel cell. Cell means that means the electrolyte is present in the same solutions, conducting in the solution which are having the same cations or as anions. So when same electrode is dipped into the solution, electrolytic solution, some that chemical reaction is taking place, and the amount of electricity produced that can be calculated. So in case of Daniel cell, what happens? Copper electrode is dipped into the copper sulfate solution, and zinc is dipped into the zinc sulfate solution. And both the solutions are connected into a salt bridge. And the electrodes are attached to a galvanometer. That is how much the amount of the potential energy is produced, that can be calculated or that can be reflected in the galvanometer. So that is the Daniel cell. What happens in Daniel cell? The zinc electrode which is dipped into zinc sulfate solution is taken in the left hand side. Copper electrode dipped into the copper solution is taken in the right hand side. The zinc electrode is acts as a negative electrode. Copper electrode acts as the positive electrodes. That is the anode and cathode, both are there. So in the left hand side, oxidation is taking place. That means it produces electrons. And in the right hand side, it accepts the electrons, that is the reduction is taking place. So this is the case. And another thing that electrolysis means in that cases, directly we can find out the current. In that cases, you can directly find the amount of current present in the solution. So as I have already discussed the electrochemical cell and electrolytic cell. So chemical, that is the electrochemical cell, that is converting the chemical energy to electricity, and here the electrical energy into the chemical energy, that is in the case of electrochemical cell. So what happens? In the case of Daniel cell, the two solutions, whatever that the electrodes are dipped into the solution, that are known as half cell. So without this half cell, both are connected, we cannot get the total electrochemical cell. Total electrochemical cell means expressing only one half cell, that will not solve our problem, or that will not give the chemical energy. So whichever the oxidation is taking place, that is taken in simultaneously the reduction potential, which is taken in the right hand side, both are connected into the series. Then only the electrochemical cell can be produced. So in case of that zinc electrode dipped into the zinc sulfate solution, oxidation is taking place. So zinc converts to zinc plus 2 electrons. Similarly, copper accepts that 2 electrons. So total, you see that zinc plus copper, electrons are cancelled. So this is known as, the left hand side is oxidation cell and the right hand side is known as the reduction cell. So oxidation and reduction taken as simultaneously, and the salt bridge is taken, that is the ions can pass through, that it completes the reactions. So from the zinc, oxidation is taking place means it produces electrons. Reduction in the right hand side is due to accepting the electrons. So both will give the electricity. So that can be calculated in this. So in that cases, the question may come, why the salt bridge is required for the Daniel cell? The salt bridge is required because the ions can be passed through the salt bridge, and the electrons also coming from left hand side to right hand side. That completes the circuit, and it is calculated by the calculator. So this is the, so what is half cell? Half cell means the electrons dip into the solution of the same cation or ion. So that is known as the half cell. In this Daniel cell, half cell means the oxidation half cell and a reduction half cell. Oxidation half cell is, that is zinc rod dipped into the zinc sulfate solution. Copper rod is dipped into the copper sulfate solution. So this is the Daniel cell. So Now coming to describe the construction of Daniell cell and the reaction involved. How is it represented? I have already discussed you what is the Daniell cell, how it is represented, and the reactions as I have already given. The oxidation cell and so what is the EMF, electromotive force of the Daniell cell? EMF of that means the electromotive force of Daniell cell. So it is the potential difference between two cells, two half cells, oxidation half cell and a reduction half cell. So how it is calculated means we have to see the total EMF of the cell, Daniell cell is equal to the right hand side, that is the reduction potential, or the right hand side potential minus the oxidation potential cell, that is the left hand side. So that you see reduction potential and oxidation potential. It is the conventional, that is the oxidation cell, the left cell, that is the negative side cell, that is taken as the minus after the minus side. So it is the convention to take this. So electrodes on which oxidation occurs is called the negative side, the anode. Electrodes which reduction takes place is still the cathode. So in that cases, the potential can be calculated in this way. So E0 of cathode minus E0 of anode. So this is the EMF of the cell, that is the. So how we predict the feasibility of the cell reaction? Feasibility of the cell reaction means you see that if the total EMF of the cell is negative, that means the reaction or the spontaneity cannot be seen in that cases. If it is positive, means the spontaneity of the cell reaction persists, that means exists. So we may take this question. Why does galvanic cell becomes dead after some time? Why? The galvanic cell dead after some time means the reaction, oxidation reaction and reduction reaction proceeds, and the net work, that is the energy produced is the increasing. If the oxidation side and the reduction side are equivalent or equal, balances together, then there will be no net change of the free energy. So that is why it is dead. Understand? So why does galvanic cell becomes dead after some time? Means this is the oxidation and reduction simultaneously takes place, and after some time there is the equivalent of the both sides of the cell potentials. That is why it is dead. Then coming to as how we will calculate the cell potential of each half cell. So as we know that every calculation there must be a standard value. So standard value means with reference to that standard value we can calculate the other. Suppose we have to calculate the density of any substance. The density of any substance with respect to density of water as 1 at standard temperature and pressure. Similarly, here we can attach a standard potential or standard electrode potential either in the zinc side or in copper side. So it is convenient to take standard hydrogen electrode. Standard hydrogen electrode, that value is 0 at normal temperature and pressure. That means 25-degree temperature and at 1 atmospheric pressure. So in case of this left hand side zinc, we have to attach that standard hydrogen electrode into the right hand side and similarly calculate this. Same as in the case of the copper electrode, which is reduced. In that case, we have to attach that standard hydrogen electrode to the left hand side and calculate. So these two values can be taken and subtracted. We will get the net standard potential of the cells. So this is the way to calculate. Another, that is the calomel electrode, is also there, but it is convenient to take the standard hydrogen electrode. In that case, equilibrium constant is related to E0 cell but not E cell. Explain why. So equilibrium constant, in that case we will take the chemical potential, that is the free energy change in the cell. Free energy change means if it is negative, free energy is negative, then it is feasible, the reaction is feasible. What does it mean? That in the chemical reaction, the free energy change delta G0 is directly equivalent to F, that is number of electrons produced. F number of Faraday is the EMF of this. So N is the number of electrons produced or involved. F is the Faraday. E is the EMF. So for standard value, if you will take minus delta G0, so it is E0 G0 is delta G0 minus RT ln A means it, that is the activity, or minus delta G equal to minus LF P0 RT ln. So this is also taken as NFE, or E is equal to minus N. You can take here. So it is E0 minus RT ln, that is the concentration. That is, so in that cases, the concentration of right hand side divided by concentration of left hand side. So it is the equilibrium system. It is the equilibrium system in that case. So the net change in potential energy depends upon this change in energy at standard state minus RT by NF. Ln, that is the concentration, the equilibrium. So here we can take as the constant, equilibrium constant K. So this is the representation or the relationship between the standard electrode potential and the net electrode potential of the cell reaction. Now, all these things, in that case, short questions are coming. So, what is the unit of equivalent conductance? The definition already we have learned that the equivalent conductance is the product of equivalent, that is the specific conductance multiplied by the concentration, that is 1000 by the normality, or in molar case, molar conductance means it is the molarity. So the unit will be how much? If you is taken the multiple choice, it is ohm inverse into centimeter inverse. Second is ohm inverse centimeter -2, and third is ohm inverse and centimeter square, and fourth is non-inverse. So in that cases, what happens? We have calculated all these things. So equivalent conductance means we have the normality. We are taking the normality of the solution. So it is ohm inverse into centimeter square or normality. So it is the third, that is third case. In that cases, we can take it. What is the effect of dilution in conductance? If the suppose the specific conductance increases, molar conductance decreases. Second case, specific conductance decreases, molar conductance increases. Third, both decrease in dilution, both increase in dilution. So in that cases, what happens? Specific conductance, as I have already told you, specific conductance decreases with dilution. That means the amount of ions present in 1 cubic centimeter is decreasing whenever you are diluting the solution. That means volume increases, so specific conductance decreases. Then in Daniel cell, zinc dipped into zinc sulfate and copper sulfate, copper dipped into copper sulfate. What happens? The zinc undergoes oxidation and copper undergoes reduction. Second, zinc undergoes reduction and copper undergoes oxidation. That is multiple choice questions. Third, oxidation reduction does not take place in the Daniel cell. Oxidation takes place in both sides, means both cases. So in the Daniel cell, as it is represented, zinc dipped into zinc sulfate solution, copper dipped into copper sulfate solution. So zinc side is the oxidation side, copper side is the reduction side. That means oxidation is taking place in case of zinc dipped into zinc sulfate solution. Reduction takes place in the copper dipped into copper sulfate solution. The second case, zinc undergoes oxidation and copper undergoes reduction. That is the correct answer. In the electrolytic cell, flow of electrons is from which side? Cathode to anode in the solution, or anode to cathode through internal supply, cathode to anode through external supply, cathode to anode through internal supply. So in that cases, in the electrolyte session, that means the supply is there. Why that means AC current is applied to that case. So cathode and anode through internal electrolyte, internal supply. Next question, the molar conductivity of a strong electrolyte. First, increases linearly with concentration, increases with square root of concentration in a linear fashion, decreases linearly with concentration, and fourth, decreases with square root of concentration in a linear fashion. So, as we have seen that when that concentration, molar conductivity of strong electrolyte, that decreases with square root of concentration in a linear fashion. Which of the following is, we have not gone today. So conductivity of an electrolytic solution depends on what? Nature of electrolyte, concentration of electrolyte, power of AC source, and distance between the electrodes. So in that cases, it depends upon only the concentration of electrolyte. It depends the concentration of the electrolyte. Next is some values we will do. For measuring electrolyte conductance, the current is used whether it is AC or DC or both AC and DC or none of these. So only AC current is used for electrolytic conductance to measure the current. Then conductance is what? Directly proportional to the resistance, inversely proportional to the resistance, equal to the resistance, none of this. As you have already, resistance, inverse of resistance is conductance. So that is why here we can take it is the second choice. Then next, each ion makes a definite contribution to the molar conductivity of an electrolyte at infinite dilution is what? Whether it is Ohm's law, Arrhenius rule, Nernst rule, or Colas law. So as we have already discussed, in case of Colas, the total molar conductivity is the contribution of individual ions, that is positive ions and negative ions, that is cations or anions, and number of cations and anions present in the solution. So that is why it is the Colas law. The relationship between free energy delta G and EMF of the cell is delta G is NFE, that is product of number of electrons, Faradays, and EMF. Delta G is minus NFE, or third, E is equal to delta G by N into F, or delta G equal to EF by N. So in that case, I've already given that either delta G is the minus NFE or minus delta G0 is NFE. So in that cases, we can calculate delta G equal to negative of NFE. Zinc reacts with dilute sulfuric acid to give gas, but copper does not, because zinc has higher oxidation potential than hydrogen. Zinc has lower oxidation potential than hydrogen. Copper has higher oxidation potential than hydrogen, or none of these. Dekho, in this case, zinc has higher oxidation potential than hydrogen. That is why first one is correct. Zinc has lower oxidation potential than hydrogen is not correct. Same as this. Next, the EMF of the cell is, first is the difference between electropotential of two half cells, the difference between potentials of two cells, the electrode potential of two cells, the electrode potential of different cells. So as we have already discussed, the EMF of the cell is the difference between the two halves, electrode potential of two half cells. So first one is correct. The reduction potential of an electrode increases with a decrease in concentration, or with the addition of other salt solution, or with the increase in concentration of ions, or with the removal of a power supply to the cell. So what happens? So it is the increase in concentration of ions. The reduction potential of an electrode increases with the increase in concentration of the ions. That means if we add some electrolytes to that, the number of ions will be more, so that electric potential will be. The EMF of the cell, when the cell attains equilibrium. Cell attains equilibrium means there is the no net EMF of the solution, so that the EMF, net EMF will be 0. That is the subtraction value. If both are this oxidation potential and reduction potential are same, that means it is equilibrium. It is in equilibrium. So no, there will be no net EMF of the cell. So it is 0. Which metal can be used in cathodic rotation? We have not some markers this. An electrochemical cell stop working after some time. Why? Or because first one of the electrode is consumed. Electrode potential of both electrodes go on decreasing. Third, electrode potential of both the electrodes becomes equal in magnitude. Electrode potential of both the electrodes go on increasing. So what is that? Electrode potential of both the electrodes becomes equal in magnitude. Then the electrochemical cell stops working after some time. So that oxidation potential and reduction potential balances each other. Then which of the following statement is true for Daniel cell? Daniel cell means current flows from zinc electrode to copper electrode. Cations move towards copper electrode. Electrons flows from copper electrode to zinc electrode. Cations move towards zinc electrodes. So as we have seen that cations move towards the copper electrodes. That means zinc, it forms the zinc plus ions, it moves to that of copper electrodes and it is deposited so that it is neutralized. So second is specific conductance, whether it decreases with dilution, decreases with increase in concentration, shows no variation with dilution, has no effect on concentration. So we have seen that the specific conductance decreases with increase in concentration, with a decrease in concentration. That means it decreases. That means so it decreases with the dilution. That means when dilution is more, concentration is decreasing, the number of ions formed is less. So that is why the specific conductance decreases. Then we have to come to next, the dry cells or cells or batteries which are formed or which are constructed for the storage purposes. So in that cases, we have two types of cells. One is primary cell and second is secondary cell. Primary cell means one is primary cell, second is secondary cell. So in the primary cell, that's taken as the dry cells. Dry cells, that is the battery. In that cases, what happens? The zinc electrode, that is the zinc container, which acts as the anode. Cell battery is, as you have seen that. So upper layer is the zinc, and inside that, that is a carbon rod is there that acts as the positive, that is cathode. So in between that, the ammonium chloride solid with the carbons, powder carbon is taking as a paste, compact with the the zinc electrode to carbon rod. So in that cases, oxidation is taking place from the zinc side, and in the carbon rod, the reduction is taking place. So it gives a potential of 1.2 to 1.4, 1.2 to 1.5 volt. So this is the dry cell. But in case of secondary cell, that there is storage cell. So it is used that battery, that is the lead storage. So lead is dipped into the sulfuric acid at a constant concentration, that is 38% concentration, and it is taken as a series. So zinc electrode and zinc sulfate. So zinc sulfate is deposited while it is charging. While it is discharging, giving the electricity, zinc sulfate produces the ions and also giving the, that is the known as the secondary cell. So it is in this case, that is the energy is storage. So recharging, recharging both are taking place simultaneously. So we have already discussed that what is the dry cell and secondary cell. So in that cases, so the load in the, you know it, or you have been used for your vehicles. Suppose in case of cars or in inverters, you are using inverter, that is this cell. So recharging, recharging, both are taking place simultaneously. So when lead storage battery is there, battery is discharged. Why? Tell me, when lead storage battery is discharged, what type of reactions is taking place? First, sulfur dioxide is evolved, lead sulfate is consumed, lead is formed, and sulfuric acid is consumed. Tell me, which one is correct? In case of lead storage battery is discharged, sulfur dioxide is not evolved in that cases. Lead sulfate is consumed, not lead, there is a discharge, lead sulfate is stored. Yes. And lead is not formed. Lead is so only that sulfuric acid is consumed. Yeah. Sulfuric acid consumed means the concentration is increased because the water vapors, heat is generated, water is coming out, vapors in vapors. That is the concentration of sulfuric acid. So that is why periodically we can add water to that to maintain a constant concentration. And if the concentration is more and the more and more, then the battery will not function. So we can replace immediately. So another thing that in case of that, the storage battery, in that cases, the rechargeable battery. What is a rechargeable battery or cell? And how it is recharged? Tell me please. And which battery will give the will be taken as a rechargeable battery? Whether it is nickel cadmium battery or mercurous oxide battery. In that mercuric battery, you see that mercuric battery, mercury is not taken. Mercuric oxide, that is salt, is taken. But in case of recharge cadmium and nickel battery, that is why it is taken as rechargeable. No ions are formed in that cases. So in case of nickel and cadmium battery, whichever is taken as the potassium hydroxide to that, that remains as it is. So it gives a constant value and it is recharged again. So question may ask to you, which type of cell is used in hearing aids? Hearing aids means it is a long life procedure. So in that cases, the battery which is used, that gives a constant potential throughout its use. So the which battery will give you that type of life? That is the mercury battery, mercury cell. So in that case, it always gives a constant potential. Then next, in which cell the free energy of chemical reaction is directly converted into electricity? Which cell the free energy of chemical reaction is directly converts into electricity? The Laplace cell, concentration cells, fuel cells, or lead storage battery? Chemical reaction taking place in case of secondary cells, that is the lead storage battery. Lead storage is that gives the concentration cells. Another thing will come to rusting. Why rusting is taking place? Corrosion, that is corrosion. Corrosion is a process that is slowly eating away the metals due to attack of atmospheric gases or vapors. So that iron is rusted. Iron is rusted. Why? Because iron is in contact with the vapor, forms ferric oxide, hydrated ferric oxide. So that gives a rusting. So if they in your pipe, water pipe, if there is some leakage, what happens to that? The rusting is more because it directly contact with the water and vapors. So rusting will be more. That means it is hydrated more and more. The oxides or iron oxide is formed more and more. That is why the rusting is more. So how we will prevent it? How you will prevent it? Either we will coat it with another metal or another material which can not be oxidized easily, or which we can take it as a oxidation side. Oxidation side means we can protect it by covering it in zinc or tin with the iron materials. So zinc will be, that is known as, sometimes nowadays the iron is amalgamated, that is zinc is there, zinc is forming with that, so that it will not taking the rusting materials. So it protects the rust. So it protects the rusting. So another thing is that Cathodical protection or electrical protection is hydrogen, and that is renewable energy, that is fuel cells. We have not discussed the fuel cells. So in case of the satellite journey, in that case we will have or we need more energy, that is renewable energy from that. So either solar energy is taken, or we can use it hydrogen oxygen reduction oxidation reaction, so that it gives the energy. So in case of that journey, what happens? If we are taking hydrogen and oxygen, it produces water, and it also ionizes as H plus ions and OH minus ions. Simultaneously, both reactions are taking place. That is why the consumption and the reduction both are in simultaneous way, so that it prevents means it prevents the loss of energy in that case. So that is why it is used in fuel cells. So now the question may come, the best way to prevent rusting of iron by what? Making iron as anode, making iron as cathode, putting it in saline water, or none of this. What happens if you take the iron rod with the saline water? Saline water means it has sodium chloride, present sodium chloride more. So it easily oxidizes sodium and chloride. So it cannot prevent the ionizing the iron. So it supports to increase the ionization, so that more and more rusting will be there due to the electrodes or electropositive ions. So if we prevent that things, that means we have to cover it with another material. What is that material? Either zinc or tin. So in that cases, what the best way to prevent the rusting of iron is that making iron as anode or making iron as cathode. Iron, if you take iron as cathode, then it prevents the rusting of the. So in case of the long questions, which type of cells are rechargeable? I have discussed which type of cells are rechargeable. Please tell me. Rechargeable, as I have already, that is nickel cadmium cell is rechargeable. Give short notes of corrosion, how it can be prevented. Give short notes of corrosion and how it can be prevented. So in that cases, you have to write the definition, what is corrosion, and the mechanism or the theory behind it, the corrosion. Theory means, suppose you will take the case of iron, it corrodes due to water vapors. Similarly, what happens? We have to see that, we have to write that iron is converted to ferrous, 2 plus ions, and giving 2 electrons, and that is also reacted with the OH minus ions, forming hydrated ferrous oxide or ferric oxide. This is the theory behind it. Then what is secondary cell? Give the cell reaction of nickel cadmium storage cell. Already discussed this thing. why a dry cell becomes dead after a long time, even if it has not been used. If you are not using it, still then the potential decreases. Why? Becomes dead. Why? Because the ionization is always continuing. Continuing, that means oxidation reaction or reduction reaction always continuing because they are in taken in the chamber which are having the oxidation reduction reactions. That is why the potential decreases. So this is the thing. Let me know if you have any doubts regarding this or whether we can have any doubt. Already the doubts have been cleared during the class hour, but here we can only discuss the short questions and the long questions. Long and that is multi-choice questions also. So multi-choice questions, we will have 4 choices, and out of these 4 choices, one is correct, you have to find out. So we have discussed many more. So accordingly, you have to prepare your own questions and answers. And okay, thank you. Just to have some break, then we will discuss the second half, surface chemistry. Why rusting of iron is more in saline water than in pure water? Discussed all these things.
Now, PGTs, just I want to give 5 minutes rest to Dr. Sao. Now, if you have got any type of difficulty in academic matters, please inform me so that I can try to sort out with your secretary and director ST. If any of you have any type of academic difficulties, please inform me so that I can sort it out with director ST or your assistant secretary MTS. Kuandu. I don't find most of you, your photo is not there. Yes, why you have you should be present on the camera or in the your mobile, because perhaps you are not aware that your assistant secretary is taking the attendance. Your assistant secretary Omtes is taking the attendance. Who are the people present or attending this training or not? So I want to tell you that just you make your own Android find, because you may get explanation from your assistant secretary. Your assistant secretary is taking your attendance, whether you are present or not. Please be careful for that. Yes, any type of academic difficulties, if you want, please tell me. Yes. Any type of academic difficulties, if you have, please inform me so that I'll try to sort it out. କୁହନ୍ତୁ କାହାର କିଛି ଅସୁବିଧା ହେଉଛି କି? ନାଇଁ, କେହି କିଛି କହିବେନି? ଆଚ୍ଛା ଶୁଣନ୍ତୁ, ଆପଣ ମାନଙ୍କର ଏଇ ଯୋଉ କ୍ଲାସ ପରେ ପ୍ରତି ସବଜେକ୍ଟରେ ଆମେ ଟ୍ରେନିଂ ପ୍ରୋଗ୍ରାମ ସରିଲା ପରେ ଏ ଯାହା ସବୁ କ୍ୱେଶ୍ଚନ ଡିଫରେଣ୍ଟ ସବଜେକ୍ଟରେ ଡିସ୍କସନ ହେଉଛି ତାକୁ ଆମେ ଆପଣଙ୍କ ଆସିଷ୍ଟାଣ୍ଟ ସେକ୍ରେଟାରୀକି ଦେଇଦେବୁ ଏବଂ your assistant secretary Jayashree madam will send it to your respective schools for the use of the students. ପିଲାମାନଙ୍କ ବ୍ୟବହାର ପାଇଁ ଯାହା କ୍ୱେଶ୍ଚନ ସବୁ ଡିସ୍କସନ ହେଉଛି, because our main target is the students. ତେଣୁ ଆମେ ଯେତେକ କ୍ୱେଶ୍ଚନ ଡିଫରେଣ୍ଟ ସବଜେକ୍ଟରେ ଡିସ୍କସ ହେଉଛି ତାକୁ ଆମେ ଆପଣମାନଙ୍କ ସ୍କୁଲକୁ ପଠାଇଦେବୁ ଏବଂ ଆପଣମାନେ ସେଗୁଡ଼ାକ ପିଲାମାନଙ୍କ ସାଥିରେ ସେୟାର କରିବେ, because they will face the first examination in November, December sometime, once the CBSE decides. Any other difficulties you face, please tell me, inform me. आपण मानकर आउ जदि किछि difficulty अछि मते जणांतु. I will try to sort it out. Are you able to hear me or not? Are you able to hear me or not?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
आपणकर अन्य किछि असुविधा होछि मते जणांतु. I will try to resolve it with the director ST.
Sir. Hello, sir.
Janantu, anything?
Sir.
Your sound is breaking. Sanatana mo.
Hello, sir.
कैमरा ऑन करियो बाध्य कले पा.
Sir.
Yes. Hey, Sanatana ko gale. Hey, no डाके टिके. एठी ब्रेक होछि कोन से पढुछंती. Yes. कुहंतु.
Hello, sir. नमस्कार. Sir, एते नवेम्बर हमरो आसरसन रिजन केस पे स्टडी करना थी तो कंप्लीटली.
हाँ नहीं सी तने क्लास ना करियो मुझे ही. Now, if you don't have, I am handing over to Sao. It's
Now we will discuss the surface chemistry. So what do you know about the surface chemistry? Surface, the chemistry, that means the reaction taking place at the surface or the interfaces of both. So, so in that cases, as you know, the solution. What do you mean by solution? Solution means a solvent which is taken in large quantity with a solute which is taken in small quantity mixed together forming the solution. That is a true solution. And suppose we will take a charcoal and adding charcoal to that solution, what happens to this? Charcoal means it is the thing, that is a substance which can absorb or adsorb these molecules. So absorb and absorb molecules means what? Suppose ink is spread over the table and we are taking a filter paper or blotting paper attached to it. So what is that? The ink is absorbed by the blotting paper or filter paper. Suppose you will take the charcoal in case of a colored substance. The colored substance is colored solution. So charcoal adsorbs the colored materials so that the solution is giving, or the color of the solution is decreasing, so that the animal, the charcoal adsorbs the colors. So this is the way to understand what is the surface reactions. Surface reaction. So charcoal which are taking, it is known as adsorbate, and the solvents which are adsorbed, it is known as adsorbent. These are two things. So suppose we are taking the ammonia, and that is we will take the calcium chloride with water vapor. So calcium chloride will absorb the water vapor. And if you will take the silica gel and the ammonia solution, what happens? Silica gel will adsorb the ammonia solution. So silica gel is the adsorbate, and this ammonia solution is adsorbate. So there is two things, that is absorption and adsorption. Absorption is taking place at the bulk, that means at the medium, and adsorption is taking place at the surface of the adsorbate. So adsorbate may be solid, gas, or liquid. So if you are taking the solid substances, adsorbate, so it depends upon the surface area that covered with the adsorbate. Surface area, how will it increase the surface area? Suppose the adsorbate is crystalline. If you powder it means we are making particles. So particles will have more surface area than that of the crystal. So that is why if powder substance is taken at the adsorbate, it will adsorb more quantity of the adsorbent, because the surface area is more. So adsorption is taking, or adsorption is the taking up of the vapor, liquid at its surface or interface. Whereas the absorption, it is a bulk phenomena or bulk process. In that cases, the concentration is also decreases in that cases at the bulk medium. But in case of adsorption, it is a surface phenomena, surface reaction, and it depends upon the whatever the amount of surface area present and adsorb the substances. Sometimes absorption and adsorption both are taking place simultaneously. This is known as sorption. surface. And why the absorption is taking place? Absorption is taking place due to physical forces and chemical forces. The physical forces is acting, that is the van der Waals forces, which absorb the molecules. So this is known as physical absorption. And the chemical absorption is due to formation of bond, breaking of bond and formation of bond. That is the chemical reaction is taking place. So that is chemical absorption or chemisabsorption. And here the physical absorption is physics. So the temperature, concentration, and the pressure plays an important role for the surface phenomenon or the surface reactions. So the absorption is a exothermic process. Why it is an exothermic process? Because as you've seen that the what is that? Attraction between the molecules is large when it is very close to each other. When there is the molecules reacting together and present in the distance places, the absorption will decrease. So that is the spontaneity of the reaction is decreasing. So as we have seen that the entropy means the disorderliness of the system. So disorderliness of the system is more, means there is more entropy. If absorption is taking place, that means the disorderliness decreases. The forces of attraction is decreasing due to absorption. When the surface is already covered with one layer, then the next absorption is decreased. But sometimes multi-layers are formed, but it is convenient, that is the single layer is more in case of the absorption. The single layer means it depends upon the entropy and the heat of the reaction as well as the temperature. So as we know that the free energy change depends upon the enthalpy H minus T into delta S. I can write it. It is the free energy change. H is the enthalpy, T is the absolute temperature, delta S is a change in entropy. So what happens? If entropy of the system is more, that is more negative, and delta that H is also more, then delta G will be more negative and negative. So more negative means it will be more absorption. If delta S, the entropy is less, the absorption is less. So in that case, if delta is negative, means it gives the heat energy. So that is why the absorption gives the exothermic process. So sometimes question ask this question: why absorption is a exothermic process? Why absorption is exothermic process? Tell me. Because the entropy of the system is negative, and if delta is still positive and delta S is more than that of enthalpy, so the net change of free energy will be negative quantity. That is why it is exothermic process. So there are two types of adsorption. Two types of adsorption. I have already discussed to you: physical adsorption and chemical adsorption. Physical adsorption is due to physical process, that is Van der Waals forces. Chemical adsorption is due to the chemical reactions taking place between adsorbate and adsorbent. So, in case of chemical reaction, what is the difference between that? The difference that involves the heat of adsorption is generally less in case of physical adsorption. Heat of adsorption is more than that of the physical adsorption. In case of physical adsorption, it is reversible, and chemical adsorption, it is irreversible. The process is irreversible, and it is appreciable at low temperature. The physical process is appreciable at low temperature. That is why physical adsorption is appreciable at low temperature, but at a high pressure. But it is opposite to that of chemical adsorption. That means it can also occur at a high temperature and also at high pressure. It is an instantaneous process, and chemical adsorption is a rapid or slow process. There are so many differences are there, you have already discussed. So main thing is that the physical adsorption is a specific process. Specific process means it depends upon the nature of adsorbate and nature of the adsorbent. That means the solvent and the amount of the adsorbate you are added to that for the adsorption. But in case of chemical adsorption, it is sometimes specific, but always it can be taking place in the normal fashion if both are reactive together. So depending upon the pressure, temperature, Henleys give a relationship with this adsorption. That is, the amount of adsorption is directly proportional to the pressure and to the power 1 by n. 1 by n means n is the constant quantity. I am writing this Henleys adsorption as per adsorption is directly proportional to pressure to the power 1 by, or A, the amount of adsorption, that is x by n. The amount of adsorption, n is the total amount of adsorbate, is directly proportional to pressure, means k is a proportionality constant, p to the power 1 by. K and n are both at the constant terms. Why we are taking the power 1 by n? N is less than that of unit. So taking log of both sides. So it is a expression of a straight line equation. So if we plot a graph, log x by m versus log p, it gives a straight line, and k is the log k is the intercept, like this. Log p log x by m, like. So this value is log k, and slope, anywhere we take a tangent and you get the slope, that value slope is equal to 1 by n. From the slope we can calculate the value of n, And from the intercept, you can calculate the value of K, the constant term. So it is giving a straight line for certain line. But actually, in experimental observation, it is seen that this straight line comes for certain pressure only. After some pressure, there is the deviation of the straight line. It is not giving a straight line, either it is decreasing or increasing. That is a curve. So why that is the trend is observed that from a limited pressure, this plot of log, the amount of absorption within the pressure, this is straight line. So the limitation is that, or the validity of this curve or of this plot shows that this observes only a certain range of pressure, only certain range of pressure and a particular temperature. So it is the taken as isotherm. So we can discuss this. So derive Henley's absorption isotherm equation. So Henley's absorption isotherm equation means we have to derive or taking this absorption with respect to the pressure. And the plot we have to find out, and from the plot we can calculate the constant value K as well as the value of N from the slope. So we can discuss something. What are the factors which influence the absorption? What are the factors which influence the absorption? All the factors, that means temperature, pressure, as well as the concentration, which can imply for this thing, which can varies the absorption. If pressure is more, absorption is more. If the concentration is more, the concentration in that cases, if you take the concentration more means accordingly you have to take the adsorbate. The concentration is more, adsorbate is more, so absorption is. But temperature, as absorption is a exothermic process, heat is generated in that case. If you increase the temperature, that means the absorption will decrease. This is the only demerits in this case of absorption. Increase in temperature decreases the absorption. Then, what are the differences between absorption and adsorption? Already discussed all these things. What is the difference between this? Then, why adsorption is always exothermic? Why adsorption is always exothermic? Tell me, why adsorption is always exothermic? From the Gibbs equation, Gibbs free energy delta G is equal to H minus T into delta S. That delta S is the entropy. So entropy is decreasing, entropy is negative, and it is more negative than that of the enthalpy. So the net free energy is a negative quantity. The negative means it is an exothermic reaction. Still, if entropy of the reaction is less and less, but the net entropy is also more than that of the enthalpy. That is why it is the negative quantity, right hand side negative quantity, that is delta G. Free energy change is negative, which is the exothermic process. What are the factors which influence the adsorption of a gas and solids? the adsorption depends upon the three things: temperature, pressure, as well as the concentration. So temperature increase means there is a decrease in adsorption. Increase in pressure means increase in adsorption. Increase in concentration means increase in adsorption. Only the thing is that temperature. Why physical adsorption decreases with increase in temperature? Why physical adsorption decreases with increase in temperature? Because adsorption is a exothermic process. So increase in temperature decreases the adsorption of the physical. That means the van der Waals forces decreases. Why powdered substances are more effective adsorbent than their crystalline forms? Why the powdered substances are more effective for adsorption? As adsorption depends upon the surface area of adsorbent, so the powder substances are having more surface area than that of the crystals. That is why increase in surface area due to powder substances increases the adsorbance. We will have the short questions. These were short questions. Adsorption is first endothermic, exothermic, neutral, or none of this. So adsorption is an exothermic process. Adsorption is more on crystal surface, finely divided surface, or a perfectly solid surface, or on regular size of solid surface. So it is a finely divided surfaces, that is the powder surfaces. A plot of log x by m versus log p for adsorption of a gas on a solid surface gives a straight line with slope equal to what? Log k, 1 by n, n, or minus log k. We have already discussed the log x by m versus log p. The slope will give the value of 1 by n, not n, or not x by n, or not minus k, log k, or not log k. Slope is 1 by n. What is slope? As we know, the equation of a straight line is y equal to mx plus c. So y versus x plot will give a straight line whose intercept is constant quantity c. Here is the intercept constant quantity is log k, as I have already. So mx, m is the slope. So slope means we have already found that the slope is 1 by n, because the power is 1 by n, which is coming as a slope. The experimental observation shows Friendly's adsorption isotherm valid a at low temperature, B at high temperature, C at high pressure, D at low pressure. Which one is correct? Experimental observation shows that Freundlich adsorption isotherm valid at a low temperature, at a low pressure, at a high pressure, at a low pressure. Because it is valid at a low pressure. Certain extent of pressure, the Freundlich adsorption isotherm. Otherwise, at high pressure or high temperature, it gives a curve, not a straight line. Reversible adsorption is the chemical adsorption, the physical adsorption, or both or none. I have already discussed the difference between physical adsorption and chemical adsorption. The reversibility is in case of physical adsorption. So that is why the correct answer is physical adsorption. The rate of physical adsorption increases with decrease in temperature, increase in temperature, decrease in pressure, or decrease in surface area. So physical adsorption increases with a decrease in temperature because it is exothermic process. Adsorption is exothermic process. So decrease in temperature favors the increase in adsorption. Which gas is readily adsorbed by activated charcoal? Which gas is readily adsorbed by activated charcoal? So the choices are nitrogen, sulfur dioxide, hydrogen, and oxygen. So activated charcoal can adsorb sulfur dioxide gas. Absorption of gases on solid surface is generally exothermic because enthalpy is positive, entropy decreases, entropy increases, free energy increases. What is that? Adsorption is generally exothermic due to entropy decrease. So net free energy will be negative. So we will proceed for colloids. Next, in that surface reaction, we will proceed for colloids. Another thing is that Langmuir adsorption isotherm is there in this case. So in that cases, the supposition is taken that the Langmuir adsorption isotherm only a single layer is possible. In case of multi-layer, we will not giving any idea of this physical adsorption to that, so that the multi-layers can be possible. That is, will be given the BET theory, which is not in your course. So now coming to colloidal state. What is that colloidal state? In case of the pure solution means on the Graham's law, it is found that substances are diffused readily in a solution medium. Diffuse readily means which will have a clear that means dissolved solution. That means the solute completely dissolved in a solution. So that is a clear solution, so or true solution. But in case of sometimes some particles remain in the solution. Particles means that is not completely dissolved in the solution. So it is not the pure solution, and in that cases, some crystalline particles still present in the solution, that is the crystalloids. But in some cases, the solids are diffused very slowly. Very slowly, that means suspended particles are present in the solution. Suspended particles, what do you mean by suspended particles? Though it is particular in nature, not dissolved in the solution, so that present neither in the true solution medium nor in the particulate medium. So in the that is in between that process, that is known as the colloidal phase. So this is known as the colloidal system or colloidal phase. That means the particles which are present 1 nanometer to 1000 nanometer, that type of particles are called as colloidal particles present in a solution, that is its colloidal solution. So suppose you will take different mediums are there, different solutions. So gas is present with the liquid, liquid with gas, liquid with solid, solid with liquid, solid in gas, gas in solid. There are various combinations are there in case of colloidal system. So gas and liquid, in that is the two phases. One is dispersion phase, another is dispersion medium. Dispersion medium means medium is large, phase is small. So gas in liquid, in case of cloud. Cloud is that water vapors are present in the air. So air means it's gas and liquid, that is vapors in the form of. So it makes the clouds or fogs or mist like that. That is the dispersion medium is gas, dispersion phase is liquid. Similarly, liquid and gas. Liquid means dispersed medium is liquid and dispersed phase is gas. But suppose we are taking surf powder in water, and when mixing together, it gives a foam. Foam is what? That means a liquid present in terms of gas. That is foam. Similarly, if we take solid and gas, solid is in dispersed medium and gas in dispersed phase. Two things are there. So solid and gas means if you take ice cream, what is that ice cream? Ice cream means the butter part is present, it is a solid, and liquid is the solvent part, that is a dispersion medium. Both are forming the ice cream. So it is a colloidal system in case of solid and gas. And suppose a jelly. What is it? Jelly is that solid in a liquid. Solid is that whatever the you can take the jellies. The jellies are in solid, present in the liquid medium. So that forms a dense substance, which is known as the jellies. Another thing is solid in solid. Suppose you are taking these gems. Gems means precious stones. So precious stones that are colored from the ruby color is that what? The chromium substance present with the another solid, that is the aluminum or any other things that gives the colored substance. So the percentage of chromium is very less, that gives the violet color, pink color, that is the precious stone, solid in solid. So these are the color mediums. So there are the alternative mediums are there. So gas in solid, solid in gas, depending upon the nature, we can get the colloidal mediums. So two things are there in that cases, lyophilic and lyophobic. Lyophilic means what? The substance which are large enough, such as starch, protein, and rubber. In that cases, the the things are mixed with a suitable solvent. Suitable solvent, that means very effective towards the combination, that gives you the lyophilic, which are lyophobic, head towards the solution, to head towards the medium, that is the lyophobic. So two things, lyophilic and lyophobic, both are, one is loving for liquids, one is the hating for the liquids, lyophilic. So question may come, what are the lyophilic and lyophobic substances or colloids? We can derive all these things. Lyophobic and lyophilic, what are the difference between that? What are the size of this lyophilic and lyophobic? We have already discussed all these things in the previous classes, but it is just a general description of this. So lyophilic and lyophobic, এটা শেষ হয়েছে, ইলেকট্রোকেমিস্ট্রি শেষ হয়েছে। ইলেকট্রোকেমিস্ট্রি ଥିଲା এটা Then preparation of all this, the colloidal solutions. So preparation, different methods are there. One is peptidization, another is Bradix method of arc process, and condensation of aggregated molecules. All these things are there. So, but things are that how we will make the colloidal solutions and how we will purify it. Purification and preparation, both are. Purification is easy, but preparation is easy, but purification is difficult. So purification, in case of this, we are making it dialysis method. What is the dialysis? Dialysis is a process in which the colloidal particles will make into the simpler particles to filter through a parchment paper or a filter paper. So making these colloidal particles to a certain size, then only we can filter it. So this dialysis method is used in a process that is where kidneys fail. So what happens that the blood purification is not taking place. So for purification, we are making the artificial procedure, that is dialysis method. In that cases, the blood is purified through this parchment paper, a separate filtration system. In that cases, the concentration of that blood will make dilute, and then only you can pass through this system. Then electrophoresis. Electrophoresis is a process. In that cases, one side we will make a concentrated solution, and on the side we will get the pure solution. So in that cases, there is the movement of particles through the passage of electricity to that. So making the electricity or passing the electricity, we can move the particles to that. Another thing is that and there are two things. We will have the Brownian motion. In that case, what happens? All the particles are moving in a zigzag fashion, not in a particular direction, not in a particular fashion, not in a particular velocity. It has all the particles are different velocity, different direction of movement, and different size of the particle. So the movement of particles from different times in a straight line path. That is the Brownian motion and Brownian system. So in the ideal gas system, there is also a Brownian movement. But in case of the colloidal particles, the same procedure is also adopted here. The particles are moving in a particular direction, not in a particular direction, but in straight line path. Then another is a Tyndall effect. Tyndall effect is that the particles, colloidal particles, that is not vision to eyes. So what happens? A particular light is inserted to that gives a sparkling light to that, and that sparkling light will be observed over the microscope. So in that cases, we will get the Tyndall effect. So thing is that, so all these things we have done it, but the question is that in that cases, so we will have the coagulation value, coagulation procedure, that is known as flocculation procedure or flocculation value, then gold number, as well as lyophilic, all these things we have discussed it. So think, what is the difference between lyophilic and lyophobic colloids? We have discussed it. You have to write in point wise. Then what is the minimum concentration of an electrolyte which is able to cause coagulation of a salt in terms as it, that is a gold number, saponification value, flocculation value, and emulsification value. So in that cases, it is depends upon the flocculation value. Flocculation value, that is a coagulation value. Another milk is what? Fat dispersed in water, fat dispersed in oil, water dispersed in oil, water dispersed in fat. But fat dispersed in water, that is milk is fat dispersed. Milk is a dilute solution. Fat is also mixed with the water. That means it is whenever you boil it or you grind it in a high, the fat will be get condensed and we can separate it. So that is why fat is dispersed in water. Absorption is already. The electric field is applied to colloidal solution. What happens? Colloidal particles move towards the oppositely charged electrode. Movement of particles in size, multimolecular colloids are formed, or none of this. In the electrophoresis, we have discussed it. Whenever you are making or applying the potential or the electricity, that colloidal particles move to the oppositely charged electrons. This is the colloid. Peptidization is a process of what? Purification of colloids, precipitation of colloids, movement of colloids, or dispersing in precipitate in colloids. What is that? Peptidization is a process of purification, precipitation, or movement of colloids, or dispersion in colloids. That is dispersing precipitate into colloidal system. Alum purify muddy water by alum, you know it. Fitkiri. Fitkiri is used to purify the water, purify muddy water. It is a process of either dialysis, coagulation, adsorption, or forming true solution. What is that? It is a process of coagulation. Coagulation, the alum, the muddy particles will be attracted, so coagulate it, and then it can settle down. Blood may be purified by dialysis, electroosmosis, coagulation, or filtration. Blood may be purified by dialysis method. the blue color of water in sea is due to what? This is the Raman's effect. Blue color of water is due to dispersion of light or scattering in the light in water. What is the reflection and refraction is taking place simultaneously in the water. So whether it is deep or not, the color will be observed. So many things are discussed here. So you can get the short questions and multi-choice questions also. So various multi-choice questions are there, opportunities is there, and you can get the number of questions and discuss it. If any difficult, you can ask me or you can discuss with me anytime. Okay.
Okay, we come to the end of the first session and we move for the second session. Just I'm giving you 5 minutes time break. You take 5 minutes leisure and the second session will start around 11:10. So please wait for 10 minutes, breakage is there. So we start the second session at 11:10. Thank you. Please come. ପାଞ୍ଚ ମିନିଟ୍ ତାକୁ 10 ମିନିଟ୍ ରେଷ୍ଟ ଦେଇଛି 5 ମିନିଟ୍ ଉଚ୍ଚାର ତମେ ଆସନ୍ତୁ ତାପରେ ବସନ୍ତୁ 5 ମିନିଟ୍ ଆଚ୍ଛା ସାଉଣ୍ଡ ଏଇଟା ରଖିବେନି ଓରିଜିନାଲ ସେଟା କପି କରିବ ବସ 5 ମିନିଟ୍ ବସନ୍ତୁ 11:10
ठीक है सर अपन तो 15 टाइम देता है चलो तो स्टार्ट कर दिया एगारटा 10 कहते तो हम तो ब्लैकबोर्ड एडी यूज करले तो कुछ असुविधा नहीं हां हां
Are you able to hear me? Dear PGTs, are you able to hear me? Madam,
Yes, sir.
Priyadarshini madam,
Yes,
ମୋ କଥା
sir.
ଶୁଣି ପାରୁଛନ୍ତି? ଶୁଣି ପାରୁଛନ୍ତି?
ହଁ ସାର୍ ଶୁଭା
Yes,
ଯାଉଛି ସାର୍।
yes. Yes. So now we move for this, move into the second session. And on my left is Dr. Prasanna Kumar Satpathy. He's a retired reader in chemistry from SCS Autonomous College, Puri. And now I request him to start his deliberation. Dr. Satpathy, please. Dr. Satpathy, please.
ଠିଆ ହେଇ କରିପାରିବେ ତ? Thank you, Professor Das. Welcome, esteemed teachers. I have been given 2 classes today for 2 hours, each class 1 hour. First, I will start your chemical kinetics. Chemical kinetics. Under this heading, I will discuss your multiple choice questions and also few long questions. First, I will discuss your multiple choice questions or MCQ. First, I am giving the introduction on chemical kinetics. Then I will start discussing MCQ, multiple choice questions. What do you know by chemical kinetics? Chemical kinetics is a branch of physical chemistry which deals with study of rate of reactions. In chemistry, you come across different types of reactions. Study of those chemical reactions is called chemical kinetics. You know what is the rate of reactions? I need not discuss detail in the class, in this class. And what are the factors which affect the rate of reactions, and mathematical expression for different types of reaction, particularly zero order and first order reactions. And then I will discuss activation energy, collision theory in brief, half-life period of chemical reactions, particularly first order reactions, and problems based on half-life period, and specific reaction rate or rate constant of first order reactions. Under this heading, I am going to discuss your multiple choice questions first, MCQ. I will dictate the question and I will give different options. 4 options will be given for each question, and finally I will give you the answer wherever necessary. In case of problems particularly, I will solve the problem on the board. First question under the heading multiple choice questions. The rate at which a substance reacts depends upon its A, atomic mass, B, equivalent mass, C, molecular mass, D, active mass. Correct? Am I audible to all of you? The rate at which a substance reacts depends upon its A, atomic mass, B, equivalent mass, C, molecular mass, D, active mass. The correct answer is active mass. The correct answer is active mass. Because you know the rate of chemical reaction depends upon the concentration, particularly molar concentration of reactants. So active mass is nothing but molar concentration, number of moles present per liter of the solution. That is your molarity. Say active mass is also proportional to your concentration. So the correct answer is active mass. Clear? Second question is, the rate of a reaction that does not involve gases is not dependent on. the rate of reaction that doesn't involve gases is not dependent on pressure, temperature, concentration, catalyst. The reaction which doesn't involve gases, no gaseous reactants or gaseous products, so definitely it will not depend on pressure. The rate will not depend on pressure. It may depend on temperature, concentration, catalyst. These are different factors, you know. Temperature, concentration, catalyst, these are different factors which affect the rate of reaction. But pressure doesn't affect such reactions where gaseous reactants or products are not involved. Clear? So the rate of reaction that doesn't involve gases is not dependent on pressure. The correct answer is pressure. Clear? Third question is activation energy. Activation energy of the reaction is the energy released during the reaction, the energy evolved when activated complex is formed, minimum amount of energy needed to overcome the potential energy barrier, the energy needed to form 1 mole of the product. Out of these 4 answers, the correct answer is minimum amount of energy needed to overcome the potential energy barrier. Am I clear? The minimum amount of energy needed to overcome the potential energy barrier. You see, the activation energy, this is your progress of reaction. Progress of reaction. In x-axis and your energy along y-axis. So this is the plot. This is your reactant. This is your product. This is your transition state. You know, the reactants must pass through the transition state before giving rise to product. Correct? So this is the higher energy state. This is lower energy state. This is also lower energy than transition state. So activation energy, this is the amount of energy. This is energy axis. This difference in energy between the state of reactant and the transition state is called activation energy. Activation energy. Correct? This is your activation energy. So it is the minimum amount of energy required to take the reactants to the transition state or activated state. So the correct answer is minimum amount of energy needed to overcome the potential energy barrier. What is the potential energy barrier? When the plot crosses the transition state, then you get the product. Correct? Reactants must pass through the transition state before giving rise to products. So the energy required or the energy difference between the reactant state and the transition state is called activation energy. So this minimum amount of energy required to take the reactants to the transition state is called activation energy. Am I clear? So next question is, which one of the following is not a first order reaction? Which one of the following is not a first order reaction? I am giving you the different reactions so that it will be easy to understand. What are the different reactions out of which you will select the correct answer? Here, first reaction is hydrolysis of methyl estate CH3CO and CH3COCH3 plus water. That is called acid hydrolysis. Acetic acid plus methyl alcohol, CH3COH plus methyl alcohol. B, ethyl acetate, CH3COC2H5 plus NaOH. This is called alkali hydrolysis, CH3CONa plus ethyl alcohol, ethyl alcohol. C H2O2 hydrogen peroxide gives rise to 2 water plus O2. 2 N2O5. N2O5 decomposes giving rise to nitrogen dioxide. Nitrogen dioxide 4NO2 plus, correct? Out of which one of the following is not a fast order reaction? Which one of the following is not a fast order reaction? Can you answer? So answer is B. Hydrolysis, alkali hydrolysis of ethyl acetate is not a fast order reaction, and other 3 are fast order reaction. Acid hydrolysis of methyl acetate, that is first order. That is first order reaction because the water is present in large excess, or pseudo-unimolecular reaction, that is also called. Clear? Similarly, your decomposition of hydrogen peroxide giving rise to water and oxygen, this is also first order. Nitrogen pentoxide to N2O5 giving rise to NO2, nitrogen dioxide. Nitrogen dioxide plus oxygen. Clear? So this is also first order. So only exception is, that is, only answer is alkali hydrolysis. Alkali hydrolysis of ethyl acetate, not acid hydrolysis. Remember, this is important question. Alkali hydrolysis of ethyl acetate or methyl acetate is a second order reaction, whereas acid hydrolysis is a first order reaction. So the answer is B. Next question is, for the reaction, listen, next question. For the reaction A gives rise to B, A to B, the rate of the reaction is quadrupled. Quadrupled means 4 times. The rate becomes 4 times, quadrupled, when the concentration of A is doubled. When the concentration of A is doubled, the rate of the reaction is R is equal to K in concentration of A to the power N. So what is the value of N? Do you follow the question? The rate of reaction is equal to K A to the power N. This equation is given. So rate is equal to R, rate is equal to K concentration of A to the power N, correct? Concentration of A to the power N. Question is, when the concentration of A is doubled, rate is quadrupled. Rate is quadrupled. So what is the value of N? N is equal to S A 1, B 0, C 3, D 2. You see, what will be the correct answer? Correct answer is 2. The value of N will be 2. If A becomes 2A, when N is equal to 2, then the rate of reaction will be quadrupled, or 4 times. The rate will increase by 4 times. So the correct answer is D, N is equal to 2. Are you clear? I think I am audible. So the correct answer is N is equal to 2. Next is, a zero order reaction is one in which the reactants do not react. A zero order reaction is one. 4 options are given, in which the reactants do not react, in which one of the reactants is in large excess, whose rate is uniform and not affected by time, whose rate increases with time. Out of these 4 answers, the correct answer is C. C you mark, whose rate is uniform and not affected by time. Zero order reaction, you know, the rate is uniform throughout. The rate doesn't change with time. That is your zero order reaction. Clear? So the correct answer is C. You know the rate expression for zero order reaction? rate is equal to minus dx by dt is equal to k. This is the expression. The concentration is not changed with time or doesn't change with time, or the rate is uniform. That is a case of zero order reaction. Very rare examples are there. You know, when hydrogen chlorine combines at constant pressure on the surface of water to give rise to hydrochloric acid or hydrogen chloride gas, that is an example of zero order reaction. Similarly, very rare examples are there in which the rate remains constant throughout, or with the time the rate of reaction doesn't change. So the answer is C, whose rate is uniform and not affected by time. Clear? Next question. For which of the following the units of rate and rate constant of the reaction are identical? For which of the following the units of rate and rate constant of the reaction are identical? I am just telling you the expression for zero order reaction. Rate is equal to dx by dt is equal to k. And for zero order reaction, the unit of rate constant and unit of rate is identical, are identical. Concentration by time, isn't it? So R is equal to dx by dt is equal to k. So the correct answer is for zero order reaction. For a zero order reaction, for zero order reaction, for zero order reaction, for zero order reaction, for zero order reaction, rate is equal to dx by dt is equal to minus or plus dx by dt is equal to k. So here the unit of k is also equal to unit of rate in case of zero order reaction. Concentration unit by time unit. If you take the concentration in moles per liter and time in seconds, you can find out the dx moles liter inverse, second inverse, or minute inverse, you can say. So the rate is the unit is identical for rate and also for rate constant for zero order reaction. So the answer is zero order reaction. Next is a problem. You see, I will solve the problem. You can also solve the problem. 75% of a first order reaction, 75% of a first order reaction was completed in 32 minutes. 32 minutes. When was 50% of the reaction completed? I think you can very easily answer by simply applying your common sense or simply applying the rate equation or rate expression for rate constant of first order reaction. So 75% of first order reaction was completed in 32 minutes. When was 50% of the reaction completed? The answer will be 16 minutes. Am I correct? If half-life period, 50% means half-life period is 16 minutes. After 16 minutes, 50% is consumed or 50% of the reaction is completed. And after another 16 minutes, 25% will be completed. So total 75% will be completed after 32 minutes. That means 2 half-life periods will be completed for completion of 75% of the reaction. You can also apply the equation for rate constant K to solve this problem also. Am I clear? So this is just a simple way to calculate the problem, and also you can apply this expression. You know, for first order reaction, K is equal to 2.303 by T log A by A minus X. You know, this expression, K is equal to rate constant 2.303 by T log A by A minus X. A is your initial concentration and A minus is the final concentration. Suppose for 75% completion, K is equal to 2.303, time required is 32 log 100 by 75. 75 completion means 25 will be there. So this is your equation 1. And for 50% completion, K will be equal to 2.303 by T. We'll have to calculate T. Log 100 by 50. Equation 2. You can solve these two equations. This is 32 and you can find out the T. Correct? So definitely the answer will be 16. You can solve 100 by 25. This will be for log 4 and 100 by 50. This will be log 2. And you can simply calculate the value will be come out to be 16 definitely. So T by solving the two equations, by solving the two equations, P is equal to 16 minutes. Here, this is the mathematical expression by which you can calculate T, or simply by common sense. If a half-life period is 16, so definitely for 75% completion, the time will be 32. Clear? Am I clear? So next question is, if the rate expression for a reaction is dx by dt, that is equal to if the rate expression for a reaction is dx by dt, dx by dt is equal to k a to the power half, k concentration of a to the power half and concentration of b to the power 3 by 2. This equation is given. Dx by dt is equal to k a to the power half b to the power 3 by 2. So what is the overall order of the reactions? Four alternatives are given. A is equal, four alternatives, A is equal to 2, A is equal to 2, A is equal to 2, B is equal to half, B is equal to half, C is equal to 3 by 2, and D is equal to 1. D is equal to 1. So out of these four answers, A, B, C, D, the correct answer is A. That is, overall order is 2 pins, A to the power half plus B to the power 3 by 2. You add them together, half plus 3 by 2. That is equal to 4 by 2. That is equal to 6. This is your overall order of the reaction. Clear? So the correct answer is 2. If the rate expression for the reaction is dx by dt is equal to k a to the power half into b to the power 3 by 2, you add the powers half plus 3 by 2, so that the sum of the powers comes out to be 2. So the overall order of the reaction is 2. Clear? Another problem you can solve in a first order reaction. Next question, in a first order reaction, the concentration of a reactant decreases from 1 molar to 0.25 molar, 1 molar to 0.25 molar in 20 minutes. The value of specific rate is. This is a problem. I will solve the problem. You can also solve the problem. The choices are, the options are A is equal to 69.32, 69.32, B is equal to 6.932, C is equal to 0.6932, and D is equal to 0.06932. Clear? Out of these values, the correct answer is D, 0.06932. Can you solve this problem? I think you can solve. I'm just giving you the answer. The problem is the concentration of a reactant decreases from 1 to 0.25 in 20 minutes. Similarly, A is equal to 2.303 by T. T is equal to 20 minutes log 1 molar to 0.25 molar. You see, this is your specific rate or specific rate constant. So put the value of 20 and you can solve. That is equal to 2.303. This is 20 in 20 minutes. Then log 1 by 0.25. This will answer is equal to 4. 4 definitely 0.25 4. You can solve this and can find the value of A. That is equal to 2.303 by 20 log 2 to the power 2. That is equal to 2.303 by 20 into 2 log 2. 2 we can cancel, this is your 10. That is equal to 0.2303 into log 2. Log 2. Simply put the value of log 2 and solve. The answer is 0.06932. That is equal to 0.06932. 0.06932. This is the value of K. Yeah? You can use this equation. K is equal to 2.303 by T log 1 molar by 0.25 molar. 25 molar. So 2.3 by 20. Time given is equal to 20 minutes. So this is log 4. 1 by 0.25. Log 4. Log 4 means 2 to the power 2. So 2 log 2. So this cancels 10. 10 you divide 0.2303 into log 2. You put the value of log 2 and solve the problem and get the value of K, which is found to be 0.06932. So the correct answer is 0.06932. Clear? This is a problem using first order equation. So initial concentration is 1 molar and final concentration is 0.25 molar and time given is 20 minutes. You can solve the equation and get the value of K. Clear? Next question. Which of the following statements regarding molecularity of the reaction is wrong? You know the definitions of molecularity and order. Molecularity is the number of molecules of reactants present in the rate determining step or slowest step of the reaction. Molecularity is simply the number of molecules of reactants. So which is wrong? That means not correct. Option A is it may be either whole number or fractional. It is calculated from the reaction mechanism. C, it depends on the rate determining step. Fourth is it is number of molecules of reactants taking part in a single step chemical reaction. All the three, B, C, D are correct. So the wrong answer is it may be either whole number or fractional. Fractional molecularity can never be fractional. Molecularity can never be fractional. So this is the wrong answer. So the answer is A. Clear? Regarding molecularity, molecularity can never be fractional. It is always a whole number. But you know, order may be 0, may be whole number, or may be fractional. Clear? I think it is clear. Next question is a pseudo unimolecular reaction. Answer A, one of the reactants in pseudo unimolecular reactions, one of the reactants is present in large excess. This is option A. One of the reactants is present in large excess. B, both the reactants have same concentration. both the reactants are present in low concentration. One of the reactants is less reactive. Which is the correct answer? You know, answer A is the correct answer. In pseudomolecular reactions, one of the reactants is present in large excess. One of the reactants must be present in large excess. I have given you the example, that is acid hydrolysis of methyl acetate. Acid hydrolysis of ethyl acetate. That is a very clear example of pseudo fast order reaction. And also inversion of cane sugar. Later on I will discuss that reaction. Inversion of cane sugar in presence of acid, that is also a pseudo-unimolecular reaction or pseudo first order reaction. Clear? So the answer is in pseudomolecular reactions, one of the reactants is present in large excess. Our hydrolysis case, in case of hydrolysis of ester, acid hydrolysis of ester, what happened? Water is present in large excess, isn't it? So one of the reactants must be present in large excess in pseudomolecular reactions. So answer A is the correct answer. Clear? One of the reactants must be present in large excess. So next question, which plot can give us the value of activation energy? Which plot? 4 plots are given. Answer A, option A is K versus T, B 1 by K versus T, log K versus 1 by T, and D C versus T. Do you follow? Do you note the options? First option is K versus T, 1 by K versus T, log K versus 1 by T, and D C versus T. The correct answer is K versus 1 by T. You can mark the plot. The correct answer is log K. The correct answer is log K versus 1 by T. 1 by T. This is the negative slope. This is suppose angle theta. Slope is equal to tan theta. You know tan theta. Tan of this angle, tan theta is equal to EA by 2.303 R. EA means activation energy. So by using this expression, by using this equation, you can calculate the activation energy. EA, slope is equal to tan theta equal to EA by 2.303 R. So by 2.33 constant, R is constant. If you know the slope, you can calculate the EA or activation energy. Clear? So activation energy for a reaction can be calculated by using the plot of log K versus 1 by T. So that is the correct answer. Correct answer is log K versus 1 by T. Clear? Which plot can give us the value of activation energy? That means by using which plot, which graph, we can calculate the value of activation energy, that is EA. So the answer is C. Clear? Log K versus 1 by T. Next question. The rate of a reaction can be increased in general by all the following factors except all the factors are responsible except one. Options are by increasing the temperature, using a suitable catalyst, by increasing the concentration of reactants, by an increase in activation energy. By increase in activation energy. Activation energy, the minimum amount of energy required to take the reactants to the activated state or transition state. So the answer is D, by an increase in activation energy. Increase in activation energy decreases the rate of reaction. So by all the following factors except one, That factor is by an increase in activation energy, the rate will decrease. Except this factor, all others are responsible for increasing the rate of reaction. A is by increasing the temperature. If you increase the temperature, definitely the rate of reaction will increase. Using a suitable catalyst, using a positive catalyst, the rate of reaction is also increased by increasing the concentration of reactants. If the concentration of reactants is increased, the rate of reaction is also increased. Except the fourth answer, that is D answer, by increase in activation energy, which decreases the rate of reaction. Correct? So the correct answer is D. Next equation, next question. Radioactive disintegration is an example of, try to understand, radioactive disintegration or radioactive decay is an example of, 4 options are given: zero order reaction, B first order reaction, C second order reaction, D third order reaction. Which order reaction? This is a first order reaction, isn't it? Radioactive decay or radioactive disintegration is a first order reaction. The equation, you know, equation for radioactive decay or radioactive disintegration is lambda, you know, radioactive or decay constant, lambda is equal to 2.303 by T, similar to first order reaction, is not it? Log N0 by N, N0 by N. This is the expression for radioactive decay constant. Lambda is a decay constant, you see, lambda is a decay constant, 2.303 by T times log N0 by N. N0 is number of atoms of radioactive element initially present. That is initial concentration, is not it? Number of atoms of radioactive element initially present. And N is the number of atoms of radioactive element present after time T. After time T, the radioactive atoms present N. So this is your initial concentration, this is your final concentration. Similar to that of first order reaction, is not it? So lambda, radioactive decay constant, radioactive disintegration constant, is equal to 2.303 by T log N0 by N. Clear? This is a first order. Radioactive disintegration is a first order reaction. Am I clear? Next question. The half-life period of a first order reaction. The half-life period of a first order reaction, say A gives rise to products. This is a general first order reaction, say, is 10 minutes. Half-life is given, half-life period is given, that is 10 minutes. In what period of times is the concentration of A is reduced to 10% of the original concentration? 10% of the original concentration. This is a different type of problem, you see. This is a different type of problem. Using same equation, that is K is equal to, the half-life period of a first order reaction is 10 minutes. In what period of a time is the concentration of A is reduced to 10% of the original concentration? So half-life period is given. You can calculate K. Half-life period is given. Half-life period is equal to 10 minutes. So K is equal to 0.693 by T half, you know, T half, that is equal to 0.693 by T half is equal to 10 minutes. 10, that is equal to 0.0693. This is K. Specific reaction rate or rate constant. So now K is equal to 2.303 by T You have to calculate T log A by A minus X. A by A minus X. 10% will be reduced. 10 is reduced to 10%. So A is 100, A minus X is equal to 10. So 2.303 by T. K you know 0.0693, 0.0693. 0.0693. This is K. 2.0 by T log initial concentration is 100 by 10. Simply you can calculate your T. That is equal to 2.303 by T log 100 by 10, that is equal to 10 log 10. Log 10 you know that is value is 1. So simply T is equal to 2.303 by 0.0693. Correct? K value known 2.303. Log 10 is 1. Log 10 is value of log 10 is 1. So simply value of T is equal to 33 minutes. 33 minutes. Correct? This is the answer. So out of 4 answer A is 26 minutes, B is 33 minutes, C is 71 minutes, and D is 90 minutes. So the correct answer is 33 minutes. You can verify at your residence. You can solve the problem and can find out the value of T. It comes out to be 33 minutes. Correct? So the reactant is reduced to 10%, means 90% is consumed. Initial value, initial concentration is 100 and is reduced to 10. So A minus X is 10 and A is 100. A is 100. So 100 by 10 is equal to 10. So log 10 is equal to 1. You put the values of K calculated from the value of T half or half-life period and solve. It is found to be 33 minutes. Clear? I think this problem is clear. Next question, for a fast order reaction, the half-life is independent of, for a fast order reaction, the half-life is independent of, 4 options are given. Initial concentration, B, Q root of initial concentration, C, first power of final concentration, D, square root of final concentration. Out of these 4 answers, the answer is A. Am I clear? The answer is A. For a fast order reaction, half-life is independent of initial concentration. There is no concentration term. You know, for fast order reaction, E half is equal to 0.693 by K. For fast order reaction, T half is equal to 0.693 by K. You do not find the value of concentration term, that is initial concentration term in this equation. Correct? No concentration term. This is K, rate constant. This is T half. This is also constant. So the value of half-life period of a fast order reaction is independent of initial concentration. That is the correct answer. The correct answer is A. Next question. Activation energy of a chemical reaction. Activation energy of a chemical reaction can be determined by changing the concentration of reactants. Option A, by changing the concentration of reactants. B, evaluating rate constant at a standard temperature. C, evaluating rate constants at 2 different temperatures. D, evaluating velocities of reaction at 2 different temperatures. Correct? These are 4 options, and the correct answer is evaluating rate constant at 2 different temperatures. I will give the expression. Correct? I will give the equation by which you can calculate the activation energy of a chemical reaction. Evaluating rate constants at 2 different temperatures. at temperature T1 and temperature T2. If you can calculate the rate constant at two different temperatures, say K1, K2, then you can find the value of activation energy. You can use this equation. What is the equation? By using the equation, that means measuring rate constant at two different temperatures, say T1 and T2, you can calculate. So equation is log K2 by K1, log K2 by K1 is equal to EA, means activation energy, by 2.303 R. T2 minus T1 by T1 T2 by T1 T2. This is the expression. Equation 1, sir. You mark this equation, log K2 by K1, log K2 by K1 is equal to EA, means activation energy, by 2.303 R, T2 minus T1 by T1 T2. That means if you can know the value of rate constant, that is K1 and K2 at two different temperatures, say T1 and T2, by using this expression, you can calculate the activation energy. So the correct answer is C. The correct answer is C. Correct answer is C, means evaluating rate constants at two different temperatures. If we can know the value of rate constants, say K1 and K2 at two different temperatures, T1 and T2, then we'll be able to calculate the value of EA, that is activation energy for the reaction. This is the correct answer. Clear? So next question is, for a fast order reaction, A gives rise to products or A gives rise to B. This is general fast order reaction. The half-life time or half-life period is 100 seconds. The rate constant of the reaction is. This is very simple. Half-life period is given 100 seconds. The rate constant of the reaction is. What will be the value of rate constant? You can calculate, very simple. TF is equal to 0.693 by K, or K is equal to 0.693 by TF. So the answer is 0.693 by 100. So the value of K is equal to 0.693 by T half. So T half is equal to 100, 0.693 by 100. So the correct answer is, you can simplify. Four values are given, four alternatives are given. First alternative is 6.93 into 10 to the power minus 3 second inverse. 6.93 into 10 to the power minus 3 second inverse. This is first option. Second option is 6.9 into 10 to the power minus 2 second inverse. C is 6.93 to 10 to the power minus 4 second inverse. D is 6.93 to 10 to the power minus 1 second inverse. So the correct answer, you can verify, 6.93 into 10 to the power minus 3 second inverse. The answer is A. 6.93 into 10 to the power minus 3 second inverse. This value, 6.93 into 10 to the power minus 3 second inverse. Very simple. You can just simplify this value, 0.693 by 100. The answer comes out to be 6.93 10 to the power minus 3 second inverse. Simply by using the equation K is equal to 0.693 by half-life period, we can simplify the answer. Next question. In a fast order reaction, the concentration of the reactant decreases from. In a fast order reaction, the concentration of the reactant decreases from 0.8 molar to 0.4 molar. You can mark, the concentration becomes half of the initial value. That means half-life period, 0.8 molar to 0.4 molar in 15 minutes. Mark the question. The half-life period is indirectly given, that is 15 minutes. That is 15 minutes. Then the time taken for the concentration to change from 0.1 molar to 0.025 molar each? I think all of you can answer. The answer is very simple. The answer is 30 minutes. Isn't it? I think I am clear. The answer will be 30 minutes, means 2 half-life periods. Half-life period is given 0.8 to 0.4. The concentration becomes half. So that is half-life period is given, that is 15 minutes. Again, the concentration decreases from 0.1 to 0.025. Means 1 half-life period, 0.1 to 0.5 and 0.5 to 0.05. So this requires a 2 half-life period. That means 2 into 15, that is equal to 30 minutes. So time required for change of concentration from 0.1 molar to 0.025 molar will be 30 minutes. That is equal to 2 half-life periods. Common sense. By using common sense, you can give the answer. And also, you can solve the equation for half-life period, that is equal to K is equal to 2.303 by T log A by A minus X. Simply, you can also use that equation to calculate the value. Clear? So the answer is 30 minutes, 2 half-life periods. Next question is, which of these does not influence the rate of reaction? Which of these? Options are given. Which of these does not influence the rate of reaction? Option A, nature of the reactants, concentration of the reactants, temperature of the reaction. D, molecularity of the reaction. What is the answer? A is nature of the reactants, concentration of the reactants, temperature of the reaction, and molecularity of the reaction. So the answer is D, correct? Molecularity of the reaction doesn't influence the rate of reaction, whereas all other factors are responsible for the rate of reaction, either increase or decrease. Nature of reactants, what will be the nature of the reactants that influence the rate of reaction? Concentration of the reaction, no, concentration is very simple factor which influences, which affects the rate of reaction. See the temperature of the reaction, you know, when temperature is increased, the value of rate of reaction increases. Only answer is molecularity of the reaction. Molecularity doesn't affect the rate of reaction. Next question, 2N2O5 gas. This decomposition of nitrogen pentoxide, 2N25. N2O5 gas decomposition, 4NO2 gas plus oxygen gas, O2 gas. For this reaction, question is, what is the ratio of the rate of decomposition of N2O5? Rate of decomposition of N2O5. N2O5 decomposes, giving rise to nitrogen dioxide and oxygen. That is your rate of decomposition ratio to the rate of formation of NO2. NO2 is formed. This is the rate of forward reaction is. Try to understand. Forward reaction is decomposition reaction. Decomposition of N2O5 giving rise to NO2. And that is also, this is decomposition and this is formation of NO2. That is also called formation of NO2. So what is the ratio between the two? The answer is, the options are 1:2, 2:1, 1:4, and 4:1. The answer is 2:1. The answer is 2:1. Why? We'll explain why the answer is 2:1. So rate of decomposition of N2O5 is equal to minus half D concentration of N2O5 concentration by dt, and rate of rate of formation of NO2 is equal to 1 by 4 d NO2 by dt. What will be the ratio? Rate of decomposition to rate of formation. Rate of decomposition of N2O5 by ratio means division. Rate of formation of NO2 must be equal to 4 by 2. You can take the ratio rate of decomposition by rate of formation. 4 will go above, 2 will come down, 4 by 2, that is equal to 2:1. So the correct answer is 2:1. Correct? Am I clear? Rate of decomposition of N2O5, this is the value, and rate of formation of NO2, this is the value. You take the ratio, the answer is 2:1. The correct answer is 2:1. Rate of decomposition to rate of formation. Next question. The time required for 100% completion of a zero order reaction. The time required for 100% completion of a zero order reaction is, 4 options are given. AK, small ak, B, A by 2k, C, A by k, D, 2k by A, D, 2k by A. These 4 options are given. Out of these, the answer is C, A by k. A by k. Why the answer is A by k? For zero order reaction, KT is equal to concentration A. That means initial concentration minus final concentration. So initial concentration, so KT, the rate constant, T time, this is initial concentration A, this is final concentration is 0. Final concentration is 0. So K is equal to, or T is equal to time required for 100% completion of a zero order reaction is, so T is equal to A by K. The answer is this. T is equal, time is equal to A by K. Correct? For zero order reaction, KT is equal to A minus 0. Initial concentration minus 100 concentration. Final concentration. As the reaction is completed, this concentration of A becomes 0. So T is equal to A by K. Do you follow? So the answer is A by K. Time is equal to initial concentration by rate constant. Next question, you can solve this equation also. A first order reaction has a rate constant. A first order reaction has a rate constant 1.15 into 10 to the power minus 3 second inverse. 1.15 into 10 to the power minus 3 second inverse. How long will 5 gram of this reactant, 5 gram of this reactant take to reduce to 3 gram? Simple. So initial concentration is 5 gram and final concentration is 3 gram. K is given, rate constant is given. You can find out the time. I have solved many problems. 4 options are given. You can try, and the answer is 444 seconds. You can solve. K is given, initial concentration is given 5 gram, final concentration given 3 gram. So equation is K is equal to 2.303 by T log 5 by 3. Only T is unknown. The answer is 444 seconds. This is option A. B is 402 seconds. C is 442 seconds. And D is none of these. D is none of these. So answer you mark 444 seconds. I have solved many problems. You can use the same formula and simplify. The answer will be 444 seconds. Clear? Next question. By increase in temperature by 10 degree Kelvin, 10 degree Kelvin, the rate of reaction becomes a double. If we increase the temperature by 10 degree, then reaction is doubled. How many times the rate of reaction will be if the temperature is increased from 303 to 353? 303 to 353. How many? That is 50 degrees Kelvin. So 10, 50. How many times? That is 5 times. Correct? So when temperature is increased by 10 degrees centigrade, 10 degree Kelvin, the reaction rate is doubled. If the temperature is increased from 303 to 353 degree Kelvin, what will be the rate of reaction? How many times the rate will increase? Option A 4, B 8, C 16, and D 32. D 32. What is the answer? Who can say? The answer is 32. You see, when temperature is increased by 10 degree, the reaction is doubled. Do you want? If the temperature increase by 50 degree Kelvin, 10 by 50 by 10, how many times? 5 times. So 2 to the power 5. That means 32 times the rate will be increased. The answer is A is equal to 4, B is equal to 8, C is equal to 16, D is equal to 32. So the answer will be 32. The rate will increase by 32 times because 2 to the power 5. 2 to the power 5. 50 degree our temperature बढ़ी जाउची. The temperature is increased by 50 degree centigrade. So by increase of 10 degree, the reaction is doubled. So by increase of 50 degree, the reaction will increase by 32 times. Means 2 to the power 5. 2 to the power 5 is equal to 32. Clear? Very important question. Entrance question. 2 to the power 5 is equal to 32 times. Next question. Which one of the following statement for order of reaction is not correct? Not correct. Mark. Which one of the following statement for order of a reaction is not correct? Option A, order can be determined experimentally. B, order of reaction is equal to sum of the power of concentration terms in differential rate law. C, it is not affected with the stoichiometric coefficient of the reactants. Order cannot be fractional. This will be the answer, I think. The answer is D. Which of the following statement for order of reaction is not correct? You know, order may be fractional, may be 0, may be whole number. So answer is D. Order of reaction cannot be fractional. This is the correct answer. Correct. Next is a reaction involving two different reactants. A reaction involving two different reactants can never be bimolecular reaction, second order reaction, first order reaction, D, unimolecular reaction. Again, I am repeating the question. A reaction involving two different reactants. Suppose A, B, C, D, isn't it? Reactants are different. Two different reactions can never be bimolecular reaction, second order reaction, first order reaction. All these three things can happen. But the answer is D, unimolecular reaction. It cannot be unimolecular because two different reactant molecules are present. So answer is unimolecular reaction. Order a reaction involving two different reactants can never be unimolecular reaction. Next question. The inversion of cane sugar is represented by the equation. I will write the equation. It is a reaction of A, second order, B, unimolecular, C, pseudo-unimolecular, D, zero order. This is pseudo-unimolecular reaction. You see, I am writing the equation. Inversion of cane sugar. The inversion of cane sugar, the reaction is cane sugar is C12, H22, H22, O11 plus water, H plus means acid hydrolysis. This gives rise to glucose C6H12O6 plus C6H12O6. Two molecules of glucose, one molecule. This is invert. This is cane sugar. Cane sugar using excess water and in presence of acid. Inversion of cane sugar. This is a unimolecular reaction. This is a unimolecular reaction. This is a pseudo unimolecular, not unimolecular. This is a pseudo unimolecular reaction. Means water is present in large excess. Large. This is a pseudo unimolecular reaction. Pseudo unimolecular. The molecularity appears to be 2, but actually the molecularity is 1 because the water is present in large excess. The order of reaction rate of reaction doesn't depend upon the concentration of water, rather it depends upon the concentration of cane sugar. This is a pseudo unimolecular reaction. Next question. Very simple question you can answer. For the reaction A gives rise to B, the rate law is rate is equal to K into concentration of A. That means this is a first order reaction. Rate is equal to R is equal to K into concentration of A. This is a first order reaction. Which of the following statements is incorrect? Not correct. Is incorrect. Incorrect. Mark. Option is the reaction follows first order kinetics. B. The T half means half-life period of the reaction depends on initial concentration. C. K is constant for the reaction at a constant temperature. The rate law provides a simple way of predicting the concentration of reactants at any time after the start of the reaction. 4 options are given. I read out the 4 options. A is the reaction follows first order kinetics. B, the T half of the reaction depends on initial concentration. This is wrong. This is incorrect, is not it? In case of first order reaction, half-life period is independent of initial concentration of the reaction. So T half of the reaction depends on initial concentration. This statement is wrong or this statement is incorrect. So this is the answer. Out of 4 options, the option B is correct. Okay. So I discussed these multiple choice questions, around 30 multiple choice questions. Next, I will discuss your long answer questions, long type questions. Then I will discuss your biomolecules. Clear? So I am discussing in brief what are the possible long questions that come out in the examination in +2 level, in higher secondary level. So see, you note down and try to practice the long questions. You can remember, very simple. And all these questions are generally comes in the examination. So what are the possible long type questions from chemical kinetics chapter? Number 1, you see, state and explain order and molecularity of reactions. You can note down. Number one, state and explain order and molecularity of reactions. State and explain. You can state the definition of molecularity, state the definition of order, and explanation is given with examples. Number two, what do we mean by pseudo unimolecular reactions? I've discussed several times while discussing your set questions, multiple choice questions. What do you mean by pseudo unimolecular reaction? All of you can answer. Pseudo unimolecular reaction means it appears to be bimolecular. Actually, it is unimolecular. That means the rate of reaction depends on the concentration of one molecule. That doesn't depend upon the concentration of two molecules. That is called pseudo unimolecular reaction. I have given you two examples: acid hydrolysis of ester and also inversion of cane sugar. This is another long question, very often comes in the examination. Third is, what is activation energy? I have discussed while discussing your short questions. What do you mean? What is activation energy? Derive Arrhenius equation. Arrhenius is not equation, derivation is not there in +2 level. Simply you can explain your activation energy and also give final expression for Arrhenius equation and give the significance of different terms involved in Arrhenius equation. This is another equation. Explain activation energy, explain graph, give the final expression of Arrhenius equation, and how you calculate the activation energy using Arrhenius equation. Simply, you can discuss this under the heading activation energy and Arrhenius equation. Fourth question, what is half-life of a reaction or half-life period of a reaction? How is the half-life period and the concentration of the reactant related to the first order reaction? You know, this is very simple. You can define half-life period, give a different example, give the expression or relationship between half-life period and the rate constant. And in case of first order reaction, that is half-life period is independent of initial concentration of reactant. All these things you can discuss with few problems. I have discussed many problems under the heading half-life period and rate constant. Clear? You can very easily explain what is half-life period of a reaction. Next is derive the equation for the rate constant of a first order reaction. Derivation of rate expression for K. Derivation for rate expression for K. Which expression you know? K is equal to 2.303 by T log A by A minus X. That expression, that mathematical expression, how will you derive for the students? How will you derive for the student? This is the long question generally comes in the examination. What is the unit of rate constant of first order reaction? What is the unit of first order rate equation? What are zero order reaction? Next question. Give two examples. Write the rate equation for a zero order expression. What is zero order reaction? Zero order reaction you can define. What is the expression for K and what is the unit of K? You can explain. All these things we have also explained while discussing multiple choice questions. The next important question is, name the factors which influence the rate of reactions. What are the different factors? You can discuss and bring to your students which affect or which influence the rate of reactions. Next is discuss collision theory of reaction rate. That is not also there in +2 level, in higher secondary level. Collision theory, the basic concept is how the molecules collide, reactant molecules collide, pass through transition state and then gives rise to products. This is the basis of collision theory or activated state theory or transition state theory. This question comes out as short note or a short question, short notes in the higher secondary examination. Next is write notes on order and molecularity of reaction, order of molecularity reaction comes also as a short note. Activation energy and RNA equation can also as short note. Write a brief account of half-life period of a reaction and factors affecting rate of reaction. All these things we have already discussed. These are the important long questions from chemical kinetics chapter, which generally come in the examination. I think your chemical kinetics portion is complete. Then we'll go to your biomolecules chapter. Biomolecules, I will discuss some portion of biomolecules, important multiple choice questions for biomolecules. You know the syllabus for biomolecules. We'll discuss few multiple choice questions today, and also we'll discuss other multiple choice questions in the next class. So we'll start your biomolecules. We'll generally discuss your multiple choice questions on the chapter biomolecules. We completed your chemical kinetics chapter, both multiple choice questions and long questions. What are the possible long questions? I have also discussed. Next is biomolecules. Biomolecules. You know, under this chapter, the portions, those are included under this heading biomolecules. You know, that is your protein, carbohydrates, nucleic acids. All these portions are there in biomolecules. Generally, your carbohydrates, it's a structure. Different portions are there under the heading, particularly your monosaccharides, disaccharides, polysaccharides. All these are there in biomolecules. And these are proteins, structure of proteins, polypeptide, peptide linkage. All these portions are there in your polypeptides or proteins, you can say. How protein molecules are polymer of amino acids. So these are also called polypeptides. Next is your nucleic acids, DNA, RNA, its structure and functions. All these things are there in biomolecules portions. Today we'll discuss few short questions under the heading biomolecules. You see, first question on biomolecules. Multiple choice questions, you see. Number one, a nanopeptide, mark, a nanopeptide contains how many peptide linkages? A nanopeptide contains how many peptide linkages? Clear? You know, proteins are also called polypeptides. A nanopeptide contains how many peptide linkages? Can you answer? Nanopeptide means 9 amino acid molecules will be joined to form this polypeptide. So this is called nanopeptide. So how many peptide bonds, how many peptide linkages will be there in nanopeptides? So the answer is, the options are A 10, B 8, C 9, D 18. Out of these four answers, four options, the answer is B. Answer is 8. Means 8 peptide bonds will be there in nanopeptide. The formula is N-1. 9 amino acid molecules are there, -1. 9 minus 1, the answer is 8. 8 peptide bonds will be there in nanopeptide. Clear? Second, which of the following exist in Jupiter ionic form? Which of the following exist in Jupiter ionic form? 4 options are given, out of which how many will give Jupiter ionic forms? Jupiter ion, you know, both the acid and base properties, both plus and minus ends are there. Out of these, which will exist in Jupiter ionic form? Options are alanine, B glucose, C fructose, D-ethanamide. Clearly understand four options are there, out of which two are correct, not one. Two answers are correct. A is alanine. You know the formula of alanine. I will write the structure, deuterium structure, glucose, fructose, ethanamide. Alanine and ethanamide both exist in deuter ionic forms. You see, alanine. Alanine CH3, CH, NH2, COH. This is alanine, amino acid, alpha amino acid. This exists in deuterionic form. CH3, CH, NH3 plus, CO minus. Correct? This is the deuterionic form of alanine. NH3 plus, nitrogen tetravalent positive, and CO minus. H plus comes from this side and is attached to amino group NH3 plus and CO minus. This is deuterion for alanine. Similarly for ethanamide, CH3CONH2, CH3CONH2. This also exists in deuterionic forms. CH2 minus, CH2 minus, CO NH3 plus. This also exists in deuterionic forms, both plus and minus. Here NH3 plus and CO minus, your CH2 minus and NH3. This is your ethanamide. Ethanamide. Correct? So the answer is both alanine and ethanamide. These two compounds exist in deuterionic forms. You know the definition of deuterion and how these molecules exist in deuterionic forms. You can mark. So the answer is 2, both A and D. Clear? Next question is, which among the following is the monomer of a starch? Which among the following is the monomer of a starch? Starch is a polymer. Starch is a polymer of glucose, you see. Because starch, when undergoes hydrolysis, this gives your glucose. This gives your glucose. So the answer is glucose. The answer is glucose. Which among the following is the monomer of starch? Option A is glucose, B is sucrose, C is protein, and D is lactose. So the answer is glucose. That means starch, when undergoes hydrolysis, this gives rise to glucose. You can see the reaction. What is the hydrolysis reaction? What is the hydrolysis reaction of starch? Starch when undergoes hydrolysis, C6H10 O5, N molecules. This is the starch. Starch plus N water, N molecules of water, hydrolysis, in presence of acid hydrolysis, and molecules of glucose, C6H12O6. This is your glucose. N molecules of glucose. And molecules of glucose. So starch, when undergoes a hydrolysis, gives rise to glucose. So glucose is the monomer of polymer, that is starch. Clear? Next question. Which of the following is are reducing sugars? Which are reducing sugars? Means can reduce your say oxidizing agents or filling solution, tolerance agents, reducing sugars. The options are sucrose, fructose, maltose, starch. Out of these, 2 are the correct answer, that is fructose and maltose. Fructose and maltose are reducing sugars. They can reduce your Talens reagent and other substances like filling solution, etc. So these are called your reducing sugars. Glucose is also reducing sugars. Glucose contains aldehyde group and fructose contains ketone group, isn't it? Both are reducing sugars, but glucose is the strongest reducing agent. Glucose can easily reduce than fructose. But out of these four options, that is sucrose, fructose, maltose, and starch, two are the answers, that is fructose and maltose. Clear? Next is the carbon atom involved in osazone formation. The carbon atoms involved in osazone formation are osazone, glucosazone, fructosazone, you know. Glucose reacts with phenyl hydrogen to form glucosazone, excess of phenyl hydrogen. Fructose reacts with phenyl hydrogen to form fructosazone, isn't it? So what is the formula of glucosazone? I will give you the structure. And which carbon atoms are involved in osazone formation? The options are 1 and 2. That means first carbon and second carbon. Option B, 2 and 3, second and third carbon. Option C, 3 and 4. D is 5 and 6. What will be the answer? Who can say? The answer is 1 and 2. You can mark from the osazone structure. You can write the osazone structure. The answer is 1 and 2. That is first and second carbon atoms are involved in osazone formation. The structure of glucosazone. Glucosazone, you see, CH double one N NH C6H5 C double one N NH C6H5 CH OH whole 3 CH2OH. This is the structure of glucosazone. Glucosazone. This structure. Which carbon? This is first carbon. This is second carbon. Then third, fourth, fifth, and this is sixth. Third, fourth, fifth. So which carbon atoms are involved in osazone formation? First and second. Clear? Do you follow? This is the structure of glucosazone, in which first and second carbon atoms are involved in osazone formation. So the answer is 1 and 2. The answer is 1 and 2. That is A. Option A is correct. Carbon atoms 1 and 2. You can mark 1 and 2 are involved in osazone formation. Next question. The bonds in protein structure, that are not broken on denaturation, four options are given. The bond that is not broken during denaturation. You know what is denaturation of protein? It is a process in which protein molecule loses its characteristics. Coagulation of protein. Its original characteristics is destroyed. That is the process of denaturation. So what bond? The bond in protein structure that are not broken on denaturation. Denaturation process. In the process of denaturation, which bond remain intact, not broken, that are not broken on denaturation. Option A, hydrogen bond, peptide bond, ionic bond, and disulfide bond. The answer you can very easily imagine. The answer is peptide bond. Peptide bond in protein is not broken during denaturation. That is the correct answer. The answer is B. That is peptide bond. Next question. Which of the following is not found in nucleotides? You know, amino acids, your nucleic acids, DNA, Na, nucleotides, nucleosides, your base, amino acid, phosphate, all these terms while discussing your protein molecules and nucleic acids. Again, I am repeating the question. Which of the following is not found in nucleotides? These are bases, nitrogen containing bases, you see. Option A is guanine, B is cytosine, C is adenine, D is tyrosine. Out of these four bases, which is not found in nucleotides, the answer is tyrosine. You can mark tyrosine is absent in nucleotides. All these three bases, guanine, cytosine, and adenine are present, while tyrosine is absent. The answer is tyrosine. That is option D is correct. Clear? Then, which of the following, next question, which of the following do not undergo hydrolysis? Which of the following do not undergo hydrolysis? Important question. Option A is glucose, B is fructose, C is cane sugar, D is maltose. Out of these, the answers are A and B, glucose and fructose. These are monosaccharides. These are monosaccharides. So these molecules are not hydrolyzed. That means they do not undergo hydrolysis. Glucose and fructose are not hydrolyzed. The answer is A and B both. Remember, the answer is A and B both. Next question. Which of the following carbohydrates is most abundant in nature? Abundant, A, B, U, N, D, A, N, T. Abundant, largely found. Abundant. Which of the following carbohydrates is most abundant in nature? Option A is glucose, B is fructose, C is cellulose, D is starch. All these are carbohydrates, no doubt. Out of which cellulose is the most abundant in nature. Most abundant, cellulose. The option is C is correct. The option C is correct. That is cellulose is the most abundant carbohydrate in nature. Here, cellulose, answer. Next, which gives a red color with filling solution? Which of the following gives a red color with filling solution? Filling solution, alkaline solution of copper sulfate containing sodium potassium tartarate. Alkaline solution of copper sulfate containing sodium potassium tartarate. That is your filling solution. Filling A is alkaline solution of copper sulfate. B is your Rachel salt, the sodium potassium tartarate. Equimolar mixture or equal amount mixture A and B gives rise to filling solution. Which of the following, which gives red color with filling solution? Filling solution is reduced to red precipitate of cuprous oxide, that is C2O, which will give option A is glucose, B is cellulose, C is benzaldehyde, D is cane sugar. Which will give red color with filling solution? The answer is glucose. The answer is glucose, first option. Why? Because glucose contains your aldehyde group. Main functional group your aldehyde, glucose in fructose, that is ketone. Aldehyde is oxidized or reduces your filling solution to cuprous oxide, red precipitate. Glucose, cellulose, benzaldehyde. Benzaldehyde is also contains your aldehyde group, but this is aromatic aldehyde. Aromatic aldehyde does not reduce filling solution. Clear? So benzaldehyde is not the answer. The correct answer is glucose. Glucose, which contains one aldehyde group that reduces the filling solution to give the red precipitate of cuprous oxide. Clear? Glucose is the correct answer. Next is on hydrolysis. Proteins give. On hydrolysis, proteins give A, nucleotides, B, nucleosides, C, amides, D, amino acids. You can know the answer. Again, I am repeating. On hydrolysis, proteins give. What is the answer? Amino acids. Is not it? Amino acid. Protein is a polymer of amino acids, means several amino acid molecules join together to give protein. So protein, when undergoes hydrolysis, will give amino acid. Amino acid. The correct answer is amino acid. Option D is correct. Option D is correct. That is, amino acid is obtained when protein is hydrolyzed. Next, the change in optical rotation with a time of freshly prepared solution of sugar is known as. Again, I am repeating, try to understand. Answer is mutarotation. That is the definition of mutarotation. What is mutarotation? The change in optical rotation with time, change in optical rotation with time of freshly prepared solutions of sugar is known as. 4 options are there. Specific rotation, inversion, rotatory motion, and mutarotation. Mutarotation. So this is the definition of mutarotation. So the answer is D. Mutarotation is the answer. So this is the definition of mutarotation. Mutarotation. That is change in optical rotation of a dilute solution of sugar. That is called mutarotation. The answer is D. Next question. Which of the following carbohydrates is used in silvering of mirrors? Do you understand this question? Which of the following carbohydrates is used in silvering of mirrors? Mirror, you know, behind the mirror, that is opaque portion. Behind the mirror, that is opaque portion for which picture comes in. You can see your face, you can see your picture because of that opaque portion. Opaque portion, that is your silver coating is given. Behind the mirror, silver coating is given, that is called silvering of mirror. That is done using glucose solution, because glucose reduces tolerance reagent. You know tolerance reagent? Ammoniacal solution of silver nitrate is called tolerance reagent. Tolerance reagent is reduced to give the metallic silver. Metallic silver. So glucose is the answer, which contains your aldehyde group that reduces tolerance reagent to give the silver mirror, or metallic silver is deposited behind the mirror. That is called silvering of mirror. So answer is glucose. Options are sucrose, cellulose, fructose, and glucose. The answer, option D is correct. That is glucose is the correct answer that is used for silvering mirror. Next is helical structure of proteins. Helix structure. You know the structure of proteins. Helical structure of proteins is stabilized by which bond? Which bond stabilizes the helical structure of protein? Options are there. Ionic bond, covalent bond, van der Waals force, hydrogen bond. What will be the answer? You can very well answer. Hydrogen bond, is not it? Helical structure of proteins is stabilized by hydrogen bond. Option D is correct. Hydrogen bond stabilizes the helical structure of protein. Next question. Glucose and fructose are. Try to understand the question. Glucose and fructose are optical isomers, functional isomers, chain isomers, position isomers. What is the answer? Functional isomers, isn't it? Functional isomers is the correct answer. Glucose contains which functional group? You know the structure of glucose? It contains aldehyde group. Fructose contains ketone group. But molecular formula is same. That is C6H12O6. Clear? So which isomeric forms? In which both your glucose and fructose exist. Which isomeric forms? That is functional isomers. Glucose and fructose exist in functional isomeric forms or two functional isomers. 19. The number of chiral carbon atoms means asymmetric carbon atoms. Number of chiral carbon atoms means asymmetric carbon atoms in beta D plus glucose. In beta D plus glucose molecule each, beta D plus glucose contains how many asymmetric carbon atoms or chiral carbon atoms? 3. Option A is 3, B is 5, C is 4, and D is 6. The answer is 4. The answer is 4. You can write the structure of beta D glucose. Beta D glucose, this is the structure. The number of chiral carbon atoms, the number of beta D glucose you see C, H, OH. Alpha D glucose C, H, OH, CH, OH, H, CH, OH, COH, H, and CH2OH. HOH, this is alpha D glucose and beta D glucose. OH will be reversed. So how many chiral carbon atoms are there? You can mark. This is first carbon, this is second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Out of these, this is not chiral. This is not chiral. So 2, 3, 4, 5. These carbon atoms are chiral or asymmetric carbon atoms. That means 4 different groups are there. This is chiral because H, OH, and this portion and this portion. 4 different atoms or groups are attached to carbon atom number 2, number 3, number 4, and number 5. You see, carbon atoms 2, 3, 4, 5 are chiral carbon atoms. Yeah? So the answer is 4. Am I clear? Next is glucose with excess of phenyl hydrazine forms. I have already discussed this question, but in different form. You see, glucose with excess of phenyl hydrazine forms. Option A, fructosazone, glucose phenyl hydrazone, glucosazone, phenyl hydrazone of glucosazone. Out of these 4 options, you know the answer will be glucosazone. Glucose with excess of phenyl hydrazine will form glucosazone. I have already discussed this question, but in different form. Next question. Protein is an important constituent of our diet. Our diet, daily diet, contains protein, several protein substances, protein diets we eat daily, like your cereals, pulses, meat, egg. These are different protein containing diets. So, but what is the function of protein in diet? It functions mainly as, what is the main function of protein? The options are a source of energy, a construction material, shock absorber, reserve food. So what will be the answer? A construction material. Protein acts as a construction material in our body. So we require in our daily diet some protein molecules, protein foods we require for construction of material, Next, the coagulation of protein is called the coagulation of protein. You know what is coagulation? Ame odiyare koi pariba jamata bandiba. Blood coagulates, protein coagulates, means jamata bandiba, solid ejiba, liquid becomes solid. That is called coagulation. The coagulation of protein is called option A, dehydration, B, decay, C, deamination, D, denaturation. Denaturation, 4 options. The coagulation of protein is called denaturation. Mind it, the answer is denaturation. Denaturation. The coagulation of protein is called denaturation. So option D is correct. Denaturation, you know, I have already told you, it is a process in which the characteristics of protein is destroyed. Characteristics of protein is destroyed. That is called denaturation. So coagulation is the process of denaturation in case of protein. Next question. A protein is best described as a protein can be described as option A, polyamide, polyester, polypeptide, polyurethane. What will be the answer? You can very easily say polypeptide, is not it? Protein is a polypeptide because it contains several peptide linkages. It is a polymer of several amino acid molecules. So proteins are also called polypeptides. So proteins are also called polypeptides. Important. Remember. Next is alpha D plus glucose and beta D plus glucose are called alpha D plus glucose and beta D plus glucose are called. We can write the alpha D plus glucose and beta D plus glucose. Will mark the difference. What is the term used to denote these structures? Option A is geometrical isomers, anomers, enantiomers, and epimers. Very important question. Geometrical isomers, anomers, enantiomers, and epimers. These are called anomers. And the carbon atom, which is linked to 5th carbon atom through an oxygen atom, that is called anomeric carbon atom. So the correct answer is anomers. Alpha D glucose and beta D glucose are called anomers. You can mark why these are called anomers. See, CHOH, 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 CH, and CH2OH, CH2OH. This is alpha D glucose, alpha D plus glucose, alpha D plus glucose, alpha D plus glucose, and beta D plus glucose, COH, H, OH towards the right. In this case, OH towards the left. Other things remaining same, CHOH, 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 CH, CH2, beta D plus glucose. We say these are called anomers. Alpha D glucose and beta D glucose. These are anomers. Everything remains same, but H on the left hand side, but H on the right hand side. H on the right hand side, but OH on the left hand side. These are called anomers, in which the first carbon atom is joined to 5th carbon atom through this oxygen. Hemiacetal structure. These are called hemiacetal structure, and alpha D and beta D are called anomers. And this carbon atom, carbon 1, this carbon 1, first carbon atom is called anomeric carbon atom. Okay? So the answer is anomers. Alpha D glucose and beta D glucose are called anomers. Next question, the number of amino acids which form proteins in nature are about. You see, how many number of amino acid molecules can form proteins? How many? I think all of you know. Option A is 6, B is 10, C is 15, and D is 20. D is 20. Option D is correct. About 20 amino acid molecules join together to form the protein molecules. So about 20 amino acid molecules are involved in protein formation. Protein formation. The answer is D, that is 20 amino acid molecules. Clear? Next, the pH value of a solution. You know what is pH? pH minus log H plus ion concentration. The pH value of a solution in which a polar amino acid means deuterionic forms of amino acid does not migrate under the influence of electric field is called, does not migrate. If you apply the electric field, the deuterionic form or polar form of amino acid do not move towards any electrode, correct? Not migrate under the influence of electric field is called. What is the term used for this? Option A is isoelectric point, B is isoelectric point, B is isoelectronic point, that is electric, this is electronic. C is neutralization point, D is none of the above. I think you can very easily answer isoelectric point. That is where there is, in this point, or at this point, there is no migration of amino acid molecules to any electrode by the application of electric field. So the answer is isoelectric point. Option A is correct. Next question, the protein which transports oxygen in the bloodstream is, again I am repeating, the protein which transports oxygen in the bloodstream is hemoglobin, insulin, collagen, albumin. You can answer hemoglobin, that participates in blood transformation. The protein which transports oxygen in the bloodstream is, oxygen transportation involves, that is hemoglobin, which is also a protein molecule. So the correct answer is hemoglobin. Hemoglobin A, B is insulin, C is collagen, D is albumin. So the answer is hemoglobin, correct? Which is a protein molecule. Next question, which of the following base is found only in RNA and not in DNA? Found in RNA but not in DNA. Which base? This base. A is thymine, B is guanine, C is uracil, D is adenine. What is the answer? Uracil is the answer. Found in RNA but not found in DNA. Answer is uracil. That is option C is correct. Option C is correct. Next question, at the isoelectric point, amino acids are present as four forms. Option A is, at the isoelectric point, amino acids are present as A, NH2, CHR, COH, B, NH3 plus, CHR, CO minus C. NH3 plus CHR COH D. NH2 CHR CO minus. These are the four options. At the isoelectric point, amino acids are present as, you see, this is the deuterionic forms, NH3 plus and CO minus. This will be the correct answer. Amino acids exist in deuterionic forms at the isoelectric point. So A is wrong, C is wrong, D is wrong, and the at the isoelectric point, amino acid exists in this structure. Here. So let us finish the today's class. I discussed about 30 multiple choice questions on biomolecules. In the next class, half an hour, I will discuss about 30-40 multiple choice questions. And in the last class, I will discuss your P block elements, particularly halogens and inert gases, group 17 and group 18 elements. In the last class, I will discuss your P block elements. Thank you, respected teachers, esteemed teachers, for attending the class. Thank you.